Hello team, welcome to my session on Coffee with Prabh, and today we're going to discuss about CISA Domain 5 Part 2. Thank you so much for sharing a great love feedback on my videos, and that motivate me to make this last series of the video. Definitely, if time permit, I will make more videos on CISA. And in this video, we're going to discuss about the Part 2 of the Domain 5, which I left. And with this, I'm concluding the domain review series of CISA, but if time permit, we'll come up with the questions also. Do let me know in the comment box, shall I make those videos also, how to break the questions and everything. And if you're new to the channel, do subscribe to the channel and click on the bell icon to make sure you should not miss my future videos on a similar topic, because I'm coming up with lot of skill-based training videos on YouTube, because end goal in next 10 years to make the content which is basically upskill your profile and get a great things on the future's perspective. So without wasting a time, let's start with the first part. Thank you. Okay, so first part we have is cryptography. I'm not going to cover in detail because there is a detailed video already there on my YouTube channel. So please check in the description box. I literally explain the entire cryptography in detail. I highly recommend before starting of this video, please watch that video, because there is a dedicated 30 minutes video I have explained about cryptography, because there's no point of sharing the same content again in the CISA. But here I'm just sharing a high level, because if you don't understand that video, you cannot able to understand this. Okay, so I literally request you to please in the description box, there is a video is there of cryptography part 1, part 2, part 3. Check that video and then play this content. Okay, but here if you already have watched my cryptography video, so let's start it. See, when you're talking cryptography is a science of protecting information by transforming into the unreadable format. So if you go by the logic also, crypto means secret, and graphy is called as a science of writing. Science of writing. So science of writing data into secret text is called cryptography. Today cryptography basically used for multiple things. Let's take an example. If A want to send data to B over the internet, and he want to make sure no one should able to read that, so he encrypt the data. Who provide this encryption? Cryptography. I want to make sure the data will be provided in the same state, and I want to give an assurance to the B that it is the same state of data we generate a hash. Who provide that? Cryptography. It is coming from me only. I want to give an assurance, so we need to add the signature. Who provide that? Cryptography. So cryptography was introduced initially for data secrecy, but today we use cryptography for multiple things. It can be used for the integrity, it is used for authenticity, and it is basically used for the other factors. That's why I say cryptography is a science of protecting information by transforming into the unreadable format, so that only authorized user can read or process it. So the goal of cryptography is to ensure the confidentiality. It means the state of information only available to the authorized user. Second is called as an integrity, which ensure the data state will remain same. And if any modification is done, we can able to track. Authentication it offer. And last is basically called as a non-repudiation. Non-repudiation basically mean the sender cannot deny for his action. It is same like, while coming back from the office, you receive a message from your partner. While coming back, please buy chocolate. You read that, okay, but you have not replied that. But the person will get acknowledgement the person has read the message, blue tick. So can you deny later? No. So this is called as a non-repudiation. The better is basically disable that privacy settings. So even you read, they will not receive any kind of a notification. So that is called repudiation. So you can deny. But non-repudiation is actually a security properties where you cannot deny for your action. So cryptography used to ensure the confidentiality. It is used to ensure the integrity, authentication, and more important, non-repudiation. That is the most important part we have. See, one thing you need to remember in cryptography is we have two important things. One is called as an algorithm and one is called as an encryption key. In same like, if you want to lock your house, so you need a lock, right? So you can say lock is just like an algorithm. and the key which is used to unlock and lock, that is called as a key. So here I'm taking one example. Algorithm is just like a logic, and key is just like a factor. So let's say example, I want to speak in Malayalam or I want to speak in Hindi. Is it clear? So I'm using one language, so that is called as an algorithm. But in that, how I'm framing a words, how I'm rephrasing the words to be used, that is basically called as a key. Okay. So that's what I'm telling you. Please watch that video. In that, I will literally explain what is algorithm and how the algorithm works. So here I'm taking one example. Plus is the algorithm, one as a factor. So I have one plain text which is called security. Now I want to send this test in a secure manner. So I'm using a base languages A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now A want to send data to B. So he decided he will use algorithm plus, and one is basically a key. So we have a S here, we have a S here. So S plus 1 is T. So T become first. E is there. E is there. So next is basically F. C is there. We have a C. C plus 1 is D. So first of all, A and B agree that we will use English alphabets. And based on that, we basically encrypt. So that's what our algorithm is called as a logic, a function, a mathematically based function that encrypt and decrypt the data. Encryption key is basically a piece of information which is used by the algorithm to encrypt or decrypt the data. In layman term, you can say encryption key is used by the algorithm to lock or unlock the data. And the third important thing is called as a strength of encryption. So strength of encryption mean, okay, I want to buy this encryption. I want to go for this encryption. So how can you analyze the strength of encryption? So strength of encryption determined by the algorithm complexity. That is a first factor. Algorithm complexity. Second is basically key called as a key length. And third is most important is key management. I repeat again, the strength of any encryption determined by the algorithm complexity. That is a first factor. Second is called as a key length. And third is basically called as a key management. Let me write down here. So when I say strength of encryption mechanism, the first is called as a algorithm complexity. Second is called as a key length, and third is called as a key management. Is it clear? So algorithm complexity, key length, and key management. So when I say key management, it means it should be very random key should be there, and key should be stored in a secure manner. See, when we're talking about cryptography, so we have a overall two type of cryptography. Have you seen, if you've seen my previous video? So one is basically called as a symmetric cryptography, and one is basically called as a asymmetric cryptography. So we have a two type of cryptography, symmetric and asymmetric. Symmetric is basically use the same key to encrypt and decrypt the data, and asymmetric use two keys. One is called as a public key, and one is basically called as a private key. So we'll discuss that. Okay. So always remember one thing from exam point of view, we always use symmetric key to encrypt the data, and we use always asymmetric for a key exchange. I repeat again, we're using a symmetric key to encrypt the data, and we're using an asymmetric for the key exchange. Okay. If you've seen my previous video, because that's what I said, if you don't go through the video, you will not able to understand this. I really put a lot of hard work on that video because I've explained the video from a more layman perspective. So please check that video. So first is basically called as symmetric cryptography. So symmetric cryptography means we are using a one key used to encrypt and same key we are using to decrypt. How? Let's take an example. We have a system A and we have a system B. Okay. So here what happened, we have a data and we have a key 1. So key 1 is used to encrypt the data and it produces ciphertext. So A will send a ciphertext. Ciphertext is called as an encrypted text. Like, you know, if you are a North Indian, I will give you in Malayalam, you will not understand this. So that is a ciphertext for you. And if you are a North Indian, you're giving me something, I don't know because I don't know Hindi. Example I'm giving. So A will encrypt the data with the key 1, which is called ciphertext. In layman term, you can say the data was protected with the password, and the password is basically key 1. So I send the ciphertext to B. Now B need a key to decrypt because B received the ciphertext. So we send the key over the network. So B use the same key to decrypt the text. So that's why we say we are using a same key to encrypt and same key to decrypt the data. The primary advantage of the symmetric key, always remember this is the exam question, is it is fast and efficient because we are using a same key to encrypt and decrypt the data. That is why it is used for encrypting the large amount of data. Today, if you see when you're watching on YouTube, any videos and all that, when you playing something on online gamings and all that, net banking, everywhere we use symmetric encryption only. Is it clear? So common algorithms we have is DES, which is the old one. Okay, the key size was 64-bit. But if you get a question, what is the effective key size? So in that, effective is 56 plus 8-bit used for parity value. And it divide the data into blocks. So they divide the data into blocks. So each block is 64-bit. It means we have a data here. So data first divide into block 1, block 2, block 3, block 4. And then each block encrypt with the 64-bit key, in which 56 actual key and 8-bit used for parity. Then we introduce a 3-DES. In 3-DES what happened? Each block encrypt thrice. So first encrypt by the 64-bit key, produce a ciphertext, then ciphertext again encrypt with the next 64-bit, then we produce a final ciphertext. So it encrypt thrice. So that's why it say 3 times is basically 64 into 3, and effective key size is 56 into 3. Then problem with the DES and 3-DES is it required a lot of computation. You know, you need a dedicated computation system to perform the encryption, which slowed down the process. And nowadays what happened, we are using a lot of applications and they want a encryption to be performed with a limited computation. And that is where we introduce the AES. Today, if you take an example, IPsec use AES. If you say TLS, use AES. WPA2, use AES. So AES is basically used everywhere. So if you get a question around which algorithm, which solution offer the good amount of security with limited hardware computation, always remember AES. So today AES is considered as the most secure form of algorithm that is basically used to encrypt the data. Is it clear? So primary advantage is faster and less computational intensive than asymmetric, and disadvantage is key distribution. So key distribution is a challenge. Why? So if you take the logic here, we have a system A and we have a system B. Okay, if I'm using a key 1 to encrypt the data and I send this encrypted data over the B, is it clear? I have to send the key also on the same channel. So if any attacker is there, he can able to intercept the data also, key also. He can able to capture both. So that is why in the symmetric, we use one technique called OOB, out of band exchange. It means we send the data by one channel and the key will be sent by one channel. So key distribution is one challenge we have, and not scalable for the large, because if we have now 3 systems, we have a system A, we have a system B, we have a system C, we have a system D. So A need a dedicated key for B, A need a dedicated key for C, and A need a dedicated key for the C. If C want to communicate, if the D want to communicate, so there's a dedicated key required. So we cannot use the same key for this. Okay, it's track the accountability. Now, so I have a sensitive data, I want to send it to you. So you are one party for me. So there's a dedicated key for that. I want to send to my friend. I cannot use the same key. Otherwise it's a breach of confidentiality. That's why for every session, we need to have a unique key. And there's a formula we are using is, the formula is n-1 divided by 2. So if we have 3 systems, 3 minus 1 divided by 2. So 3 minus 1 is 2, 2, 3, 6. 6 divided by 2. So total we need 3 keys. Here we have 3 keys. 1, 2, 3. Each user we need to have a 3 keys. Is it clear? So this is basically the concept of symmetric cryptography. Okay, so next is called as a asymmetric cryptography. Now, when we're talking about asymmetric cryptography, it uses 2 keys. It is called as a key pair. So we have a system A, we have a system B. Each system basically have a 2 keys, public key A, private key A. Public key B, private key B. So let's take example. This is my data. Okay, I want to send this data. If I use my public key, I need to share my private key, because if I use my public key to encrypt, I have to use my private key to decrypt. Same with applicable for B also. So, but I want to make sure this data only read by B. So A will request his public key. B will share his public key. A will basically encrypt the data with the public key of B and send it to the B. So when B receives the data, it will be only and only decrypted by the private key of B. So by this way, data can be only read by B. So that's why we say we use 2 keys, public key to encrypt and private key to decrypt. But you know, it look easy in a diagram, but when you encrypting and decrypting, it requires a lot of computation. That is why I said we use both. We use asymmetric to exchange the key, and we use symmetric to encrypt the key. So if time permit, I've explained you with the diagram. So so key feature is public key is basically shared, private key is secret. In more layman term, you can say you're sharing your account number. That is a public key. You can share with anyone, but you will not share the PIN. You will not share the password to open the net banking account, because that is something your private key. So public key is shared, private key kept secret. It is slower than symmetric, definitely, because one portion of a key required to encrypt the data, one portion of a key required to decrypt the data. And the use cases, it is used for securing the email, digital signature, SSL certificate. So 2 common algorithms we have, RSA and ECC. This is important. RSA is the old algorithm, but it required so much computation to perform the encryption. So that's why the alternate of RSA today we use ECC. Even your Google homepage for the certificate, they use ECC. Bitcoin, blockchain, they use ECC, because ECC provide the same level of security with a smaller key size. So you can say RSA start with 1024 bit, where the ECC offer the same level of security at the 224 bit of key. Because RSA was a prime factorization algorithm, where the ECC is a discrete logarithm. So one thing remember, the primary advantage of symmetric, it is faster. And primary advantage of the asymmetric is key exchange. Okay. So advantage is simplify key distribution, support the signature and non-repudiation. Disadvantage is that slower than symmetric and larger key size often need to maintain the strong security. That something is there. Understood? So that's something we need to understand. So let's understand the entire cryptography. But before that, I want to also discuss one more concept, which is called as a digital signature, because that is also important. See, what happened is, and it's a very important topic. Okay, so let's take example. We have a system A and we have a system B. Okay, and this is my system C. So C public key is available to A and available to B. Okay, so they have a public key of C and they have a public key of C. So if A and B want, so if I'm using only asymmetric cryptography, okay, I'm only using asymmetric cryptography. So A will use a public key of C to encrypt the data, and B is using a public key of C to encrypt the data, and both will send a encrypted data to C, encrypted data to C. Is it clear? So C receive 2 version of encrypted data. C receive 2 version of encrypted data. Now question is how the C will decrypt. C will use its associate private key to decrypt the data. But so we achieve confidentiality because it is only read by C. But the question is, who sent which data? Because this public key is shared with everyone, right? So it is difficult to track. That is the reason we introduce the concept of digital signature. What does the meaning is? If B is sending a data, this is the data we have. So we generate the hash value first. Hash is basically called as an integrity state. Okay, like current state of data is a hash. So hash is just like a stamp. This hash produced by me mean B, he encrypt the hash with his private key. Is it clear? And create a digital signature. And then they append the digital signature with the data. So now B, when sends the data to C, when C receives the data, and there's a digital signature, first we verify the signature with the public key of B. If we're able to decrypt the signature, it gives the assurance it is came from the B. So by having a signature, it gives me assurance it came from B. So that is called authenticity. And if I'm able to decrypt and verify yes, then in that case, B cannot able to deny. That is called non-repudiation. Because our public key is available to everyone. So in this case, we assume public key is already there. So I skip that step. So by this way, we are basically achieving a non-repudiation and authenticity. So let me explain this entire process with a diagram. So that basically give you a very good clarity. Now, if you can see this diagram, just give me a second. Okay. So we have a sender and we have a receiver. Okay. Now sender want to encrypt the data. So he use symmetric key. Another name of symmetric key is called as a session key, which basically produces a ciphertext message. CTM stands for ciphertext message. Okay. And I sent this ciphertext message to the receiver. Now receiver want to decrypt. So I want to send the symmetric key. Symmetric key encrypted by the receiver public key. You can see receiver public key, which produces ciphertext key, and ciphertext key decrypted by the receiver private key. So by this way, he got a symmetric key, and with that he can able to decrypt the data. So if you can see the process here, the first step is message was encrypted with the symmetric key. Symmetric key is also called as session key. So don't get confused. Okay. And that is basically sent as a ciphertext key. Then ciphertext key decrypted by the symmetric key. And then that symmetric key I will basically use to decrypt the ciphertext message. Is it clear? So that is a first step process. Here my goal is basically achieving the, you can say, confidentiality. Now I want to give an assurance the message is coming from sender only. So we generate a hash, digest is called as a hash, encrypt with the sender private key, and append as a signature. And then signature is decrypted by the sender public key. So that give the assurance it came from the sender. Is it clear? So this is called as a concept called digital envelope, in which we have covered all the steps. Hope this is basically clear to everyone. Right? So PKI, benefits, PKI integration, everything I already covered in my description video. Please check that. Okay. That is there. Now we are moving to the next step, which is called as a quantum cryptography. Okay, so next topic is called as a homomorphic encryption. See, one thing is that we have a 3 states of data. 3 states of data. Data at rest, data in use, and data in transit. Data at rest means it resides somewhere in a storage. So we can encrypt. Data in transit, we are sending from one network to another network, we can encrypt. But data in use, right now I'm running a PPT. It is in use. We need to process data. That is the data in use. So I want to maintain the confidentiality. I want to maintain the security while data in use. And that's why the new concept came in the market, which is called homomorphic encryption. So any question talking about what kind of a solution we have by which we can able to maintain the encryption while processing data, that is called homomorphic encryption. Is it clear? So Google has introduced their concept called confidential computing that is actually built on the concept of homomorphic. Today, if I'm talking about AI models and all that, when they basically processing data, they also use the homomorphic encryption. So we don't need to go in technical of that because it will take another time, but you need to remember, in order to process data in encrypted states, that is called as a homomorphic encryptions. So it enables the computation in encrypted data without decrypting it. So normally what happens, if you want to process, you need to know the data, right? Simple is, if I'm a Malayali, and I'm a Malayali, come on, I'm a Malayali, and I understand Hindi. That's a different story because I studied Hindi medium and all that. But if I don't know Hindi, for me, I cannot able to process. So I need to first decode in Malayalam, then only I can understand. But here what happened, without decoding, I can able to process data. So they use external labels and all that by which they're able to process the data. So that's why I call enable the computation on encrypted data without decrypting it at first. And the result when decrypt matches what would have been obtained if operation were performed on the plain text. So benefit is that preserve the confidentiality while still allowing the data process in the cloud and reduce the risk of data exposure during a computation. But as I said, it comes with a challenge. It required a lot of computation. Sometimes it may be slow for the large scale data. And the research continues to optimize the performance for real world application. As I said, Google already introduced this technology, which is called confidential computing. So yeah, when you using a homomorphic encryption, performing an operation encrypted required the significant processing power. So this is the exam question. The biggest concern with homomorphic encryption is it required a lot of CPU intensive activity. Second is managing keys for partially or fully homomorphic scheme can be intricate, especially when dealing with the multiple users. And although promising for privacy preserving computations, the real world deployment remain limited due to the performance and complexity. So that something is basically there. So the biggest concern with homomorphic is basically the computation issue. Now next topic is basically called as a Kerberos. Okay. Kerberos is called as a three dogs. A Kerberos is a keyword. It's a Greek word. It means a dog have three heads. And Kerberos basically offer or SSO solution, single sign-on. Is it clear? So let's understand the primary challenge what we've seen in the enterprise, because in the first part of the video, I already covered the federation part. So let me explain you this. So we have a system A. Okay, or let's say example, this is a user A. Okay, so we have a user A and we have a system B, we have a system C, and we have a system D. Okay, if user A want to access B, user want to access C, and user want to access D, he need to remember the username and password of B, C, and D because he want to access the target resource. And every time we are sending the password over the network, we're sending a password over the network. So there is a possibility attacker can able to monitor and intercept this password. So more password frequencies are exchanged over the network, more chances are there to get compromised. So, and second thing is that as a user, I need to remember the username and password of all three users, which is always a challenge. So to overcome that, we introduce the concept of the Kerberos. We introduce the concept of SSO. It means login once, authenticate once, and based on that access the resources. And the best example you can see Gmail. So you log in once with the Gmail. From there you can open drive.google.com. Will it ask for the username password? No. You can basically type doc.google.com. Will it ask for the username password? No. So that is a live example we have for the SSO. So SSO is basically a concept where you log in once, you authenticate once, and based on that you can able to access the multiple resources without sending a password. So let's understand how Kerberos work, because that is something testable in the exam. So let's take example, this is my server. This server is called as a KDC, Key Distribution Center. Key Distribution Center. It is also called as a TGT, Ticket Granting Server. It is also called as a domain controller. Okay. You can say domain controller. It has a two major services. One is called as a AS and one is called as a TGS, Ticket Granting Services. And this is the printer I want to access. Or this is the file server I want to access. Let's take a scenario. So now what happened? This is my computer A. First of all, if you want to access printer and file server, he need to be member of domain. So how to join domain? So right click on the My Computer properties. There is an option called Advanced, and there is an option called as a work group. you have to select the domain. So you select the domain, you enter the domain name, you automatically send the request to AS. Actually, if you see the logic, these two are called as a KDC. KDC is a server under which we have a two main services. One is called AS and TGS. So A request to join domain. AS basically asks for the username password. A provide the username password. Against that AS, okay, so first, second, third. Fourth step, AS will issue the TGT. This is the exam question. Who issue the TGT? So AS issue the TGT. Is it clear? AS issue TGT. TGT is just like a passport. Is it clear? It is just like a passport. If you want to travel a particular country, you need a passport, right? So AS issue the TGT. Now he was a member of a domain. Now he want to access a printer. So AS, A send copy of TGT to TGS. TGS based on that issue a SST. Issue SST. SST is what? Service session ticket. That SST is required to access a particular printer. Now he want to access the file server. Again, he send the copy of TGT to TGS. He issue the new SST, and based on that, he can access the particular file server. So here we have a two type of ticket. One is called as a TGT, which you get once you log in. And to access the particular servers every time, we need to get a SST. Is it clear? So Kerberos is a third-party authentication service using a symmetric cryptography. And here we have a KDC. KDC basically have a two service. One is called AS and TGS. So in this case, if the AS and TGS is down, everything is down. So it's very important to protect that. So TGT issued by the AS after initial user authentication, and service tickets obtained from a TGS to access specific resource or application. So this is something you need to know from the exam point of view. Is it clear? So advantage is that no repeated transmission of user password, because once you got the TGT, I don't need to send again and again. Okay, there's a dedicated video I made. Okay, SAML Federation Kerberos. I will share in the description box. You can check that. So we have a time base, so it reduces the risk of replay attack because we are not sending password, we're sending a ticket. But disadvantage is that if the KDC is down, everything is down. We need to make sure we should have a proper time synchronization between the issuing ticket and all that. Let's say example, today we revoke the ticket, but my system is configured with the yesterday time zone. So according to that, the ticket is still valid. So ticket is very important, because if someone capture the ticket, he can resend the ticket to gain access. Is it clear? So that is the most important part we have that we need to understand. So next topic is called as a SSH, secure shell. Before going to understand the SSH, let's understand the original concept of DOS based system. So we have a system a DOS based system where we used to have a command interpreter system, and we have a B, which is a command interpreter system. Okay, so A want to take the remote access of the B command system. So from here, I will, whatever the command I enter, this command is default enter in the B system. Is it clear? So we used to have a telnet for that. You know, if I basically go to the CMD, let me show you that. So if I go to the CMD, I will type telnet. I'm just giving example, and the destination IP address, like example 10.0.0.1. Okay. So if I enter, I will get a command interpreter of the 10.01 system. So now whatever I execute from here, it is remotely execute on the destination system. I repeat again, remote command. Okay. But the problem with telnet is that telnet send the data in a plain text. Whatever the communication is happening between A and B, anyone can able to intercept that. Today we are using the remote command for executing the functions on the remote systems. Like I want to remotely execute command on the firewall, remotely execute the command on the servers. So we use a lot of remote command protocols, and telnet is one of them. But problem with telnet is that whatever you're sending, it can be intercept. So that is why in order to secure that communication, we introduce a concept called SSH, secure shell. So it's a secure protocol for remote access, command line login, and data transfer. This is the pointer you need to remember. And it replaces the older protocols, insecure protocol like telnet and FTP. So it has a three feature. First is feature called encryption. It protects data confidentiality over the network. That's a one feature. Second is authentication is there. It supports the password based public key private key method. Third, it offers the integrity, because whatever the message we have, it generate the hash, and that is basically maintain the integrity. So we have a use cases like if you want a remote administration on the server, we use SSH. If you want to have a secure file copy, we use SSH. We are tunneling the other protocol by using SSH. So key considerations we have, like organization should track and periodically rotate the SSH keys. One thing is that the SSH work on the port number 22. If this server is exposed on the internet, so same 22 port can be used to penetrate and gain access to the servers. Is it clear? So it's very important to see how you block the port number 22, because SSH use port number 22. Let's take example, this is the firewall. Accidentally the port number 22 with public IP exposed on the internet. So any hacker can target on port number 22 a brute force attack by which you try to gain access to the firewall. So we need to see how you consider that. Second is we have to enable the logs, so we can able to detect all the unauthorized login attempts and potential brute force attacks. So you have to see how can you restrict on port number 22 a particular IP. That is basically possible. Now next is basically called as a DNSSEC. Very, very important. DNS is a service which translates name to IP, IP to name. As a human, it is difficult for me to remember the numbers. So what is the process is, we have a user here. Now please listen this carefully. We have a user. Okay, this is my web server, website. Okay, and the website is running on the IP called 1.1.1.1. And this is the DNS, which has a cache maintain 1.1.1.1 mapped to fb.com. So user reach out to DNS and say, hey boss, where is fb.com? fb.com is basically on 1.1.1.1. And based on that, he opened the website. But here is a catch. The catch is there is an attacker. He also hosts his website. Okay. Hosted by hacker. So now what happened? Hacker basically push this DNS. Hey, I'm your authorized DNS server. Please find the new updates. And without verifying, DNS update the entry called okay. So new fb.com on 2.1.1.1. And that is a website hosted by the hacker. So next time when you say where is fb.com, instead of saying it will say 2.1.1. So instead of it connecting with the right website, it will connect to the fake website which hosts a phishing page, look like a Facebook page. And he basically provide the page. So based on a trust, he will share the credentials and store here. So that is basically a concern. That's why we introduce a new concept called DNSSEC. DNSSEC, domain name server security. So now if this DNS server receiving any kind of an updates, make sure it receiving from his authorized DNS server. This DNS maintain the public keys of their authorized DNS server. Public key of the authorized DNS server. So if any DNS server sending an update, he first verify the signatures. So let's say example, this is the DNS server who providing a service. And he getting an updates from the multiple DNS server. This is the 1, this is the 2, this is the 3, this is the, so whenever they're sending an updates, they encrypt that resource request with the private keys. And this DNS maintain the public keys of the trusted DNS server. So until unless they don't verify, they cannot update. So this is called as a DNSSEC. So by this way, we can ensure only authorized updates are updated in the DNS. Second is we can also have a zone restriction. So DNS store the record in a form of zone. So by disabling the zone transfer, no one can able to update or no one can able to retrieve the configurations. So DNSSEC is very important. Okay, so DNSSEC provide the DNS origin authentication, data integrity, and authenticate denial of services. Is it clear? So the functionality what the DNS basically carry here is DNSSEC use signatures to validate the DNS records. It thwarted the attack like DNS cache poisoning. I have shown you the DNS cache poisoning only by verifying the response comes from legitimate source. And the benefit is that harden for the attacker to hijack the DNS response and ensure the domain name resolutions are basically trustworthy. But challenge is sometimes when you're deploying the DNS and maintaining a public keys on all systems will always a challenge. Second is DNSSEC sign record can increase the packet size and impact the bandwidth. That's something you have to consider. Okay, so we have a next topic, which is called email securities. See, when you're dealing with emails, you will see a lot of threats. So first is called as a spam, where you receive an unsolicited bulk email, which is used for phishing or malware distribution. Like, you're receiving a marketing mail, you're receiving a lottery email. That is called as a spam and all that. Now, when we're talking about phishing, we have a 3 type of phishing. One is called as a simple phishing, where I send an email to everyone. Second is called as a spear phishing. Spear phishing is basically where I'm targeting a particular company, like my target is IBM or my target is ABC company. But there is one more concept we called as a whaling. Whaling is like I'm targeting a specific senior management of that company. So spam is where we're sending a bulk emails to the multiple people and doing a marketing and all that. That's why most of the mails goes on a spam. So that is basically one thing. Next is spoofing, where I will spoof your email ID and through that I will send an email to someone else. That is also possible. There's a lot of email servers are available, which is called open mail relay, through which I can able to send any domain email to any domain server. So that is possible. This is only for education purpose. Okay, so if you go by the concept called, let's say example, there is one website which is called EMKI. As I said, this is only for education purpose. You can add the name to what is the name you want to display on the email, what is the email ID you want to display, to subject. So when I send an email, the person will receive with the subject and the display name will be mentioned you want to spoof. So that is basically called as a spoofing. Third is called business email compromise, where we target the organization by impersonating the executives or vendor to trick the recipient to transfer the fund. Come on. If you receive an email from your boss, transfer the fund, with that pressure you might transfer. So we have a lot of security solutions by which you can able to protect the emails. The first, we use a MOS. MOS stand for MIME object. Now what is MIME? When you're sending an email, it has to be sent in a particular format so that your mail server understand, and your application, when you download the mail, when you check the mail, you can able to understand. So it need to be present in a particular format. So MIME is the extension to support the email format. Traditionally, what happened when you receive any attachment, you have to download the attachment. Then your existing application support that attachment, then only you can able to open the document. But today, if you notice, you can able to open directly a document in the Gmail. You can directly open the videos on a Gmail. You can directly open the PDF on a Gmail, because now Gmail support that advanced MIME extension. So MIME is used to support the emails format. Now, we have a docx file. It will be only supported by Microsoft. You have a text, it is supported by Notepad. So same like MIME is the extension for the file version to support the extension. So MIME is applied to the cryptography protection to the MIME data. Then we have a PGP. PGP use asymmetric encryption and digital signature to secure the email. So today what happened, so we have a system A and we have a system B. Okay, so we have a system A and we have a system B. So these are the emails we have. Hypothetical scenario, these are the emails. So emails need to be protected with the one key. Email need to be protected with the password. So now when I send this email to B, B will use the same password to decrypt the email. So PGP we have to install on the both end. PGP we have to install on the both end. So by which you can able to protect the emails. So it is primarily used to achieve the confidentiality. Third is called as a DKIM. Now mail is actually came from a respective domain. So let's say example, the mail has to be come from a Gmail, right? The mail has to be come from a Gmail, right? So mail has to be come from a Gmail. So Gmail, whenever user sending an email, Gmail basically attach the signature with his private key and send it to the destination server. So destination server maintain the public keys of the associate servers. So by this, they can able to verify the mail is actually came from Gmail. So in this website, if you notice, the website mention is basically EMKI. Okay. But here the name I'm mentioning is suppose KK prab@gmail to, so display name it will show Gmail, but reality the mail is actually came from EMKAI. Is it clear? So we need to give an assurance the mail is actually came from Gmail, nothing else. Is it clear? So whenever any mail go through any domain, they add their signatures. Okay, they add their cryptography signatures just to verify the mail is came from the same domain. Next is called as SPF. So in the same domain, there's a lot of email servers we have, but these are the only authorized email server to send an email. So that's why we call it as SPF. So SPF allowed domain owner to specify the authorized mail server to reduce the spoofing. So thin line difference is DKIM provide the assurance the mail came from a particular domain, what they claim to be. And in that domain, we have a dedicated server who are authorized to send an email. So that is something called as a things. So now we have an audit procedure for PKI. I skipped the PKI because I already covered the PKI in my previous video. So please check that in the description box, it's there. So now what happened is, in order to audit the PKI, first we need to identify the PKI roles and responsibility. You need to determine who create, approve and manage the certificate. You need to verify the separation duties between the critical certificate administrator and system operator. That something is a process we have to follow. Second thing is that we have a called as a review the policy procedure. So you have to ensure the policy for certificate issuance is there, renewal is there, and revocation is there. We also need to check for the key management guidelines. Okay, including a key generation, backup rotation and destruction. Next is inspect the physical logical security. You have to evaluate all the HSM for secure storage area for private keys. We need to confirm you have adequate access control around the CA servers and key storage. We also need to examine the certificate lifecycle. We need to confirm the CA follow the appropriate process to revoke the certificate. Okay, is the CRL and OCSP is working effectively? Then we look for the SS compliance. Okay, where we validate the things, we ensure the cryptography algorithm key length met the industry standard, and more important, we evaluate the monitoring login. We confirm the events are logged. We check for the periodic reviews. All those things need to be done. Is it clear? So these are the basic activities we have that we need to follow. Okay, so next topic is called as a virtualization. So virtualization enable the multiple operating system, multiple virtual systems or operating system to run on a single physical host. And the biggest reason of introducing the virtualization is to utilization of the hardware. Let's take example. This is my one hardware. I install one operating system, and then on top of it, I install one application. That application demand dedicated kernel. Now we need to install one more application which demand dedicated kernel. But problem is that we can only run one OS. So we need to buy unnecessary new hardware. But now what happened with the one hardware? I can basically install the operating system, and then I will install the VMware workstation. And then I can able to create a multiple operating system. So virtualization, this VMware workstation is called virtualization softwares, by which I can enable to run multiple OS in a one common hardware. Now here what happened, we have a two type of virtualization. We have a hypervisor and we have a hosted one. So when we say hypervisor is called as a type 1. And hosted one is called as a type 2. Always remember type 1 is more secure. I will tell you why. Type 1 is we have a hardware server. Directly we install the way we have a Microsoft, Linux, same like we have a dedicated operating system for a virtualization, which is called as a ASXi from VMware or Hyper-V from Microsoft. And then on top of it, I will run the multiple machines. This is basically called as a type 1. But hosted one is called type 2, where we have a hardware. Then I will basically install the Microsoft or Linux. Then I will install the VMware workstation. And then I will run the multiple machine. It is called type 2 because we have a layer 1 and a layer 2. Parallelly, we can run other application also. That is why it is more vulnerable, because it can increase attack surface. Someone can install some malicious application from there. They can be able to compromise the operating systems and target other. But in this case, I need to protect only one layer. So that is the benefit we get when you're talking about the requirement. So here, when we're talking about the functions and everything, so bare metal is a hypervisor, and hosted one is called virtualization architecture. So benefit is that better utilization of hardware resources, You can have a quick provisioning, snapshots and resource allocations, because you can create a snapshot of the VM, and a VM can run in a separate container, which can reduce the risk of cross containment if properly configured. But we have some risk. If hypervisor is compromised, everything is compromised. Managing, so you need to introduce a strong change management process. And performance issue is there if multiple VMs compete for limited resource, because by end of the day, all the VMs are sharing the same hardware. So as an auditor, we need to ensure proper governance of the virtual machines. Role-based access need to be given, by which we can have a limited impact, review the network segmentations, and check the compliance with the same principle and best practice used for the physical infrastructure. That something is a best practice we have. Is it clear? Now, next is basically called as a containerization. So containerization is a form of virtualization that package application in a lightweight, isolated environment is called container. Let me explain you. See, now we decided we will use virtualization. Okay, so we have a hardware here. On top of it, I basically install the operating system, which is a Microsoft or Linux. Then I basically install the VMware workstation. And then I create a virtual machine. My one virtual machine basically have a space of 4 GB. What I'm running in this 4 GB, 500 KB application. It means unnecessary waste of resource. 500 KB of application we running in the machine, which is a 4 GB machine. Unnecessary waste of resource, because what I need, I want to host a 500 KB application. So give me the space for the 500 KB. So that is why today we're using a concept of Docker, the container. So we have a hardware now. We have an operating system. We install the Docker. There is an application called as a Docker. And with the help of Docker, I can able to run a dedicated container. And that container is basically the environment of running the package. What is my package? I want to run the package of 500 KB. So I will take the space of 500 KB only. And tomorrow, if I want to move that particular application, I will have a hardware, we have a OS, we have a Docker. I just need to move that container. That's it. So it seamlessly, we can able to move container from one particular server to the servers. So one concern is there is that when we say this is my hardware, this is my operating system, which is basically a kernel for me. On top of it, I install the Docker. So kernel is using an existing Docker, which is basically host the multiple applications. So one kernel share with multiple container. But if you take the example of virtualization architecture, we have a hardware, we have a hypervisor, and then we have an individual virtual machine. So individual virtual machine is running a dedicated kernel. So which one is more secure? Shared kernel, shared security, dedicated kernel, dedicated security. Definitely dedicated kernel, dedicated security. So in this scenario, containers share the host OS kernel, unlike virtual machine that run a separate OS. Okay. So that is a concern. So popular tools we have using for the container is that Docker, commonly used for building, shipping and running and Kubernetes is for the orchestration. So advantage is that faster deployment. What is the meaning of faster deployment? Faster deployment means the containers are lightweight. We can start quickly. Okay. Second is platform agnostic. It doesn't matter what is the backend we have. We need a container environment in which I can run any application. So it can be deployed on any host OS. Third, improve security. The isolation approach helps to limit if one container is compromised, it limited to that only. Promote flexibility. You can able to facilitate the continuous integration deployment with CI/CD. Most important, enhance the operational efficiencies. Multiple containers can share the resource, and cost reduction because it lower the overhead compared to full VM environment. We don't need to host a dedicated machine now. Disadvantage, definitely. Disadvantage, the host dependent is there. We have a lot of dependencies. Kernel vulnerability is there. If the vulnerability we found in the kernel, from there we can able to compromise the entire Docker. Network complexity from the integration perspective. So that's something we have to understand. So the difference between the kernel and the virtualization is, from isolation point of view, containers share the host OS, where the VM includes separate guest, as we discussed. Container typically use few resources. And from a security model point of view, VM offer the full isolation at hardware level, where the containers are basically rely on the kernel based isolation. That something is there. So next topic is called as a cloud security or secure cloud migration. Secure cloud migration mean we have an on-prem scenario. and we're moving to the cloud. This is basically cloud. So what is the best practice moving from your on-prem, the one which you control, to cloud? And what are the security parameters? As an auditor, what are the things I have to audit? So that we need to cover here. So cloud migration involve moving the organization application data from on-prem to the cloud. It is easy in the case of IaaS, but difficult in the case of PaaS, because in a PaaS, see, you're running one application environment. You're planning to migrate the application environment on the cloud. So you have no visibility about how the platform the cloud is going to provide you. And tomorrow, if they're going to exit and all that, how you managing the application has become a challenge. So we have a 3 type of migration. One is called on-prem to cloud. It means you have an in-house and you're moving to the cloud. Second is called cloud to cloud, where you're moving from AWS to Microsoft, Microsoft to Alibaba. And hybrid is basically some of the sensitive applications, source code, you keep it in on-prem, and rest of the application you're moving on the cloud because of availability and all that. But when you're moving on a cloud, we face some kind of a risk. The first risk we have is compliance risk. So data protection and privacy law introduce a complex requirement. See, you have something which is under your control, so you can manage everything. You have an end-to-end visibility, but when you're moving in the cloud, you have a limited visibility. So organization makes sure that it should be comply with the regulatory and all that during a post-migration. Let's take an example. This is your company A. You decided to use a CRM of the third party, which is hosted on the cloud. So there is a subject who reach out to you. So subject want to open an account, the user want to open an account, and you updated their information in the CRM. So tomorrow, any kind of a security breach happen in the CRM, it is you who answerable to the customer. If tomorrow any kind of a downtime is there in the customer, it is you who answerable to the customer. Is it clear? So it's a very important part. So compliance is the first thing. Second is you have a very limited visibility, because till the time you have in-house controls and everything end to end. In the case of external cloud, it can limit the organization ability to monitor the control infrastructure and directly, and proper logging and monitoring are essential to maintain the visibility. Third is data remnants. See, the way you delete data on-prem is completely different from deleting a data in the cloud. So in cloud, you're deleting a soft deletion. You cannot delete physically. So only solution we have is crypto shedding or crypto eraser, by which you encrypt the data and store the data in the cloud. Then we have a shared responsibility. As a cloud service provider, some layer of security, but the organization retain the responsibility of others. And secure DevOps pipeline. So attacker may target the development and deployment process during a migration. And we need to have a proper continuous security checks and automate the testing, which basically reduce the vulnerability. So these are some of the practice we have that we follow. Now, along with that, we follow some kind of a mitigation strategy. The first is called security assessment. So before you migrate, do check the CSP security posture and compliance. Then instead of doing a migration in one go, do the migration of phases, especially if it's a complex architecture. Third, maintain the robust backup in a multiple location, because if one cloud is down, a zone is down, so you should have a backup on the alternate, and it can give you multiple benefit. One is called availability of data, and second is you can also get the visibility of the ransomware protections and all that. Because if attacker basically hack into one infra and he encrypt the file, then it is a problem. Next is called cloud security posture management. So we are using a tool that monitor the cloud configurations and alert on misconfiguration and policy violations. So these are the specific things we have. Along with that, we need to have a strong change management. So any kind of a changes we have in the cloud infra and all that. So document all the migration steps, roles and responsibility to ensure the accountability, because tomorrow if any failure happen, we should know the reason for that. So that's why we need to document all the changes. See, when you're talking about responsibility metrics, so in the case of IaaS, the provider secure the hardware and hypervisor, right? Which is discussed in the previous domain also. Let's say example, this is the hardware and this is the hypervisor. What we provided to the customer is a virtual RAM, CPU and storage. So you decide what OS you want to install on that. So that is called IaaS. So customer basically secure the OS, customer is basically secure the application on it. So you can see like that customer has a more visibility in the case of IaaS. Second is basically called as a PaaS, platform as services, where provider manages the runtime environment and you manage the security on the application data. The third is basically called as a SaaS, where the provider manage almost everything. You just need to manage the data as a customer. So as I said, responsibility metrics, but as I said, in all three conditions, data is a responsibility of the customer, governance is a responsibility of the customer. And if you want to address all the governance requirement and all that, it need to be addressed through the contractual agreement. You cannot assume that, okay, yes, in CISA we learn that it is a responsibility of the cloud provider, it is a responsibility of the customer. No, we need to bring that in the contract. So we can have a detailed contractual agreement which specify which party handle audits, incident response, and breach notifications. That something is there. But when we're going for the shared responsibility metrics, we have some challenge. First is that misunderstood the boundaries. So if responsibilities are unclear, undocumented, security gaps can be occur. Second is lack of transparency. So customer might not have a complete insight into the CSP internal control. So he was an impression, okay, this is the level of control I have, and this is controlled by the cloud provider. And this is basically where we involve the auditor. So first thing is that verify the contract. Writing, it does not mean happen. Go look and verify. If the cloud provider says that, okay, we will provide you 27,000 controls and all that, ask for the audit reports. So always remember one thing, writing, it does not mean happen. Go look and verify. Check the roles, check the responsibility SLAs. Do they clarify all the parameters? Second is assess the CSP security controls. Confirm the provider meet the relevant standard like SOC 2, 27,001 and all that. And third most important part is review the customer control. So ensure the organization implement the strong identity and access management for the data access function. So these are some of the best practices we have that we need to follow. So these are the best practices we have that we need to check. Okay. Now we have some key risks in the cloud environment. The first is called identity, credentials, and key management. What is the meaning? So whatever the credentials we have are mismanaged. So mismanaged credentials enable unauthorized access. You delete the account as per your assumption, but account is still there. Attacker can misuse that account and can use against your infrastructure. And to address this, make sure you should have a proper IAM policies. And whenever you create an account according to the scheduled process, we can destroy the account. So this is the something a practice we follow. Second is insecure software development. So vulnerabilities in the code library can lead to compromise. So we make sure we should have a proper continuous patches, and scannings are critical. That's something is a best practice we have. Third is unsecure third-party resource. Unsecure third-party resource basically mean you rely on the external repository like services, GitHub, which introduce a vulnerability, and it is basically lead to dependencies. And then we have accidental data disclosure, where the employee of the cloud provider share the sensitive data. DLP could not able to control that. So we need to have a proper DLP encryption to protect this at least, because by DLP we'll make sure data should not leave in unauthorized manner in the cloud. Then misconfiguration and exposed services. Misconfiguration, exposed services like, open ports are there, weak permissions. So make sure we should do the proper regular audits, and configuration reviews are essential. Then there's also possibility of cloud data exploitation, where the attacker exploit the network pathway and steal the information. So make sure we should have a proper assessment and everything that need to be considered, which is basically a good practice we have. Okay, so next topic we have is called as a SDN. It's a very important topic. SDN, software defined network. So SDN is a very important thing what we use in the network today, which is called as a software defined network. So if you go by the statement, it say decouple the network control plane from the underlying physical device. What is that? Let me explain you. See, suppose this is your Lenovo laptop. Can you run Mac on this Lenovo laptop directly? No. You have a Mac laptop. Can you run Microsoft in this? The answer is no. But yes, it is possible to run on this Lenovo a Mac by installing the VMware workstation. So by running a VMware workstation, I can create a virtual machine which is software in nature, and I can run any OS on this. Same in the Mac also, I will install the VMware workstation, and when I'm creating a machine, I can run any kind of an OS there. So it is not a hardware dependency. Same thing happen in the network. So instead of hardware itself is creating and managing a network, we are using software to create a network. Let me explain you. So this is my system A. This is my system B. Here we have a enterprise network. We have a router 1, a router 2, router 3, router 4, router 5, router 6, router 7, router 8. Now, if I sending any data, each and every router use their own configuration, use their own logic, here logic called control plane. And based on that, they pass the data. So let's say example, data go to the router 1. Router will follow their logic. Either it can be sent by this route or either it can be sent by this route, but it can be also sent, right? I'm just giving example. So I have to go to each and every router and understand the things, and according to them we need to configure. Might be this router is a Cisco's, this is a router is Juniper, this is a router is Huawei, and each and a router, when they're running their own vendor specific things and all that, some limitations are there. So instead of each and every router decide how to forward the data, they basically pass this entire logic. They transfer their brain that someone else can think about that, and that is called as a controller. It is same like now when before you coming from a CISA videos, you have a different mindset. So I bring everyone who come from a different mindset, and I try to refurbish your brain with a new thought process what isaca want. Understood? So I am your controller, but the controller receive the instruction from the application plane, which is also called as a management plane or application plane. So here the routing is happen, filtering is happen, who send the instruction to controller, and it is a controller who get the task done how to pass data from one location to other location. So now when A sending a data, it is a controller who analyze the logic, validate the logic, check how can we pass the data. So in this case, if the controller is down, everything is basically down. So instead of hardware itself creating a network, we are using a software. Same like in laptop, you want to run multiple operating system. So you install the virtualization by which you manage the multiple machines. So instead of hardware as a logic can decide, no, I will only run Microsoft. With the help of VMware, I can able to run any operating systems. So in SDN, we have a key component called data plane, which is an infrastructure plane where we have a physical routers and everything. Then we have a control plane with centralized intelligence that set the policies and network configuration. And finally, we have a management plane, which is an administrative plane. So let me explain again. This is my system A, this is my system B, and this is my enterprise where we have our routers. This is basically called as a data plane slash infrastructure plane. Then we have a controller here. That is called control plane. And then we have a management plane, which is called as a application plane. So if the controller is down, everything is down because they all are sending an instruction to controller only. It is a controller who get the task done from these devices. So instead of each and every device follow their own logic, it is a control plane who decide how to pass the data. So what is the advantage of? The primary advantage you will get is centralized control, because instead of each and every device manage their own parameter, it is a one center who can manage everything. Second is network programmability. So it enables the automated provision and dynamic adjustment through the API. Third, increased flexibility. So it allows the rapid scaling or reconfiguration to meet the business need. And fourth is called openness. It often built on the open standard and promoting the interoperability with third-party solution, and lower the operating cost because it simplifies the network operations and reduce the need for a specialized hardware. But as I said, it comes with the major concern. The one is called centralized point of failure. If control logic is down, everything is down. Limited management, because from application point of view, we have a very limited visibility. So that is basically concern there. I have a dedicated video on SDN explaining about how SDN works. I'll try to share that in the URL. Otherwise, you can type SDN Prabh, you will get that video. It is a whiteboard presentation about how the SDN works. Okay, so next topic is called as a DevOps, development and operation. See, we have a two type of SDLC. One is called as a iterative, and your traditional method was non-iterative. So when I say iterative, you're interacting with the customer on a regular basis where you share the status, update the status and all that. Non-iterative is basically you understand the requirement and then you release the application after 6 months. There's no meeting, there's no discussion is happening. Is it clear? So DevOps is an example of the iterative. So here we have a development and here we have operations. We have a development and we have operations. So operation team is basically maintaining a repository. There is one pipeline we called, that pipeline is basically called as a CI and CD. So in this case, what happened, developers build module by module. And once the module is ready, they parallelly release this module through this pipeline. This pipeline will discuss further stage. This pipeline is basically develop, integrate, test, and release in the repository. So all the modules are keep it in the repository, and based on that the application is running, because today the modern application is microservices where individual modules coming from multiple source use one application. So the biggest reason of going for DevOps is basically help the developer who build the software and operation team who run the software work together to smoothly, so the software can be developed faster, test it better, release more often, and fix quickly. So now what happened, the application already running based on this repository. Now we release a module. After that, the application creating an issue. So we know after this particular application module only the application creating trouble. So we can rectify easily. But once I release the entire application one go and tomorrow any error is there, so it is difficult to track which portion of the code is basically created trouble. So in DevOps, we bridge the gap by making sure both team collaborate from day one using an automation tool and shared responsibility. And that's why we have a two principle here, CI and CD. CI mean every time someone write a new code and it automatically tested and integrate with the main code base. And CD is basically where the tested code is automatically deployed to the production, which is also called as a staging server. When you're introducing a security into that become a DevSecOps. When you're introducing security which is run parallelly in your development, testing, and operation, that is basically called as a DevSecOps. So we don't bolt security at the end. We bake from the day one. That's why they follow the one approach which is called shift left. Shift left strategy basically means instead of adding a security during a development, we introduce security from the design stage itself. And the primary benefit of introducing security as early as possible, you can save cost and time. Nowadays what happened, we're using a pipelines, automated pipelines by with parallelly we're scanning the tools, containers, infrastructure configuration, and release the things. So what is the benefit of the DevSecOps? The first primary benefit we get is faster remediation. So security issues are found and fixed earlier. Second is improved collaboration, because now development team and operation teams are basically working together. So cross-functional teams share the responsibility of the secure deployment. Third, reduce the risk, because here we're doing a continuous testing. But as I said, the new threat which is introduced by DevOps or DevSecOps, which was not there in traditional SDLC, is lack of segregation of a duty, because there is a dedicated development environment, testing environment, which never interfere with the production environment. But in the DevOps, they are working together. So team must adopt a new process and share the ownership of security task. And we tool also need to require the proper integration for the pipeline, so by which we can able to release the code. Next important thing is called as a mobile, wireless, and IoT. Very common thing today used in the industry. And one thing which is very common in all three is basically a physical device loss or theft. So what is IoT? You know, the MG Hector car, or nowadays what happened, we have a smart cameras. With the help of one app, you basically control everything. So let's say example, there is a user connected with the app, and through app, he able to manage all the devices. That's why called Internet of Things. It means the things which is connected on the internet. Hey Alexa, hey Siri, with the help of instruction, they execute data. That is a IoT, Internet of Things. Or, you know, we have a car nowadays, with the help of app, you can able to control the cars and everything. That is another example of IoT. So one thing which is common in mobile, wireless, IoT is the physical device lost. So the malicious outsider can steal these devices, which lead to the data breach. Unsecure network, so data transmit over the public Wi-Fi can be intercepted. That is another concern. Then sometime when you purchase a device from the vendor is providing a misconfiguration or default configuration. Let's say example, you purchase a modem, you take an internet connection. So with that, there's a modem comes, right? No one even reset the passwords. So hackers basically misuse this opportunity, try to exploit those passwords through which they try to gain access to your modems. When you're talking on malware, mobile malwares can be propagated via SMS, WhatsApp, drive-by download to compromise the data. And we also have an unauthorized installation, where the user might install some unverified app, introducing backdoors and spyware. So always remember one thing, but the most effective security control to keep the data in the mobile is encryption. So in the worst case, even you lost a device, still your data is safe, because data is basically encrypted. So that is something as a practice we have to follow. So first thing is that we use encryption. Second is called as authentication. So when you're talking about authentication, make sure we can enforce a strong passcode or biometric. Endpoint management. So we can install the MDM, mobile device management, by which you remotely manage the devices. So we have a centralized solution. I'm going to discuss in the next slide. It's a centralized solution from which you remotely manage all the devices. Regularly patch. So keep device OS updated to mitigate the known vulnerability. And last but not the least, acceptable use policy. So you can educate the employees about the safe practice and corporate data handling. So these are some of the practice we have which we can follow. So what is MDM? See, we have now a centralized server. We have a centralized server, okay, from which we can able to remotely manage a mobile devices, which can be tab, laptop or mobile, primarily mobile or tabs. Because nowadays what happens, a lot of things are happening on the mobile. You access your mails on the mobile, you access your documents on the mobile. So that's why we need a dedicated solution to remotely manage the device. So it's a solution to centralize control of mobile devices, including a configuration, security and application deployment. So we have some core functions of MDM. The first is called device enrollment. What is that? For whenever a new employee joins the organization, he get a new device. But before that, we enroll the device in the server. So we have a serial number and everything. Whatever the policy you want to enforce on the mobile device, we can enforce from this particular platform. That is basically called as a policy enforcement. Third, we have application management. We can distribute and with the help of this centralized server, I can able to block the sites. From the centralized server, I can decide what kind of a sites you can able to open on these devices. So that is also possible. What kind of an app you can able to install. And tomorrow, if your device is lost remotely, we can able to wipe the data, locate the device, destroy the device. Everything is possible. So that is where the best practice when you purchase a mobile device. Okay, only allow trusted app which maintain the good hygiene. Second is document updates, roles, responsibility for MDM changes. When you install the MDM agent, so there is an agent we install on the mobile device which create a container. So we keep all the data in the container. So let's say example, we have a MDM server. This is my MDM server. This is the mobile device 1, mobile device 2, mobile device 3, mobile device 4. So there's a container we have. So we'll keep, this container is called as an agent, which creating a container and it is creating a logical isolation. So we keep all the data in that container. So tomorrow if the device is lost, still your data is secure. And make sure we can track the compliance, generate the alerts and everything. So these are some of the practice we have to follow when you keep the mobile devices. Is it clear? So the now question is, what is the risk? As I said, with the mobile device, the risk is data leakage. Is it clear? So you're mixing your personal and corporate data, which can lead to the accidental international exposures, intentional exposure. Your device can be prone to malware, so personal device may not be adequately protected. Loss or more devices accessing network require additional bandwidth, security control, so it impacts the infrastructure strain. So whenever any employee join, make sure properly patch the systems, sign the AUP policies, define who pay for data usage and device repair, and during an exit plan, what is the strategy we have. So this is all part of a bring your own device. Is it clear? That's something we will consider. Now the next practice, very, very important, is called audit procedure for mobile device. The first thing is that asset management. You have to check whether asset management process in place. You have to check whether we can able to track all the authorized mobile devices, because until and unless you don't have any inventory, how can you do the audit? So asset management is very important. Ensure that proper monitoring and reporting of the device inventory has to be done. Otherwise difficult to track. Second most important practice is security monitoring. You need to verify security monitoring systems capture mobile device activity, evaluate the device as centrally manage everything. Third, we have a BCP-DR. Confirm you have a BRDC process. Consider mobile device in the recovery scenario. During a satellite channel, during the mobile device network is not working, we need to have an alternate channel by which we need to convey the things. And ensure all the testing of BCP-DR plan, include the mobile device restoration access control, has been done. Awareness training, make sure we review the employee trainings to ensure they understand the mobile security risk. Example, they should be familiar with the phishing, data handling and all that, and check the policies for the secure device usage and regular updates. And last is called as a BOID, bring your own device. So we need to evaluate the BOID procedures to ensure the secure environment and policy enforcement and consistent application installation. So we need to also verify the personal device accessing the corporate data follow the security requirement. Like, do they have a proper encryptions, passcodes? Those things need to be validated. And that something is a best practice we have that we need to follow. Okay, so next topic is called as a mobile payment system. So mobile payment system mean by using a mobile applications or mobile, you're doing a transactions, and mobile payment system refer to a payment transaction carried out by a mobile device. So we have a different type of mobile payment system. You're using a UPI. Those who are from India, they're using a UPI to transfer the money. That is also kind of a mobile payment system. But we have other also, like we have one called digital wallet, just like Apple Pay, Google Pay. So we store the virtual version of credit card, debit card for a contactless payment. Then we have mobile wallet. Mobile wallet similar to a digital wallet, but may also integrate by the loyalty card, coupons, or peer-to-peer payment. Then we have a digital currency wallet, Bitcoin, which is used for storing, sending, receiving cryptocurrencies. And then we have a contactless payment system, which use NFC, or similar technology, which is called as a tap to pay. So these are basically called as, but as I said, it comes with a lot of threat, like phishing is there. Click on the link, reset the password, malicious apps which can fetch your details, trying to tamper the app, unauthorized access to your payment wallets, and they try to intercept the data. So we have some controls. The first is called encryption. So whenever you're doing a transactions, the data is encrypted. We replace your credit card with a token number and it's sent over the network, so that no one can able to, even they intercept the data, they cannot able to find anything from there. So in tokenization, we replace the entire credit card data with the secure token and we send that token over the network. It is same like when you go for any party outlets and all that, you give your car key. We have a valet parking, right? Against that, they give you valet number. So they will show that valet number and you get the car key and then you drive your car. So that valet number you take in the party, even in misplaced, nothing will happen. So same like here, when you swipe your card in the POS device and all that, your information is replaced, completely replaced with some alternate value. And that is basically check in the database. We also need to use strong authentications. Let's say example, use biometrics. So use your biometric fingerprints to access the app, or use a multi-factor, or you can have a dedicated hardware and software module to store the sensitive information. So these are the practices we have that we follow. In my previous slide, in my previous domain, I already covered the wireless security. So here we're going to discuss about the high level wireless security. So normally in the wireless network, the most important practice, we have to use strong encryption, because you're sending data over the wireless network. It must be encrypted. WPA2 use 128, AES, WPA3 use 192. If you're getting a question which is the most secure, WPA3 is the best answer. Second is MAC filtering. You can restrict the list of, so you can only allow a list of MAC address. Anything which is not in the list, they cannot connect with the Wi-Fi, even they know the password. We do the regular monitoring, regular scanning for the rogue access point or unauthorized device that we look for. We have a IPS to detect and block the suspicious wireless traffic. So these are some of the traffic. These are things which we can basically work on it. Along with that, we are using 802.1x for the network authentications. We are using WPA2 with AES CCMP for the stronger encryption. One thing you need to remember, AES used in CCMP, so overall solution we called as CCMP only. Then we are using TLS for the transport layer security over the network. Now question is how to audit the wireless. So first we have to check the governance section. For governance, we verify the policy procedure. Do they have a policy procedure exist for wireless usage and security? That's something we can look for. We also check if the organization security framework include the wireless technology. Second, we have a configuration management. We ensure change management system is in place for wireless configuration. The change has been recorded. We also need to evaluate the default access points settings. Then we have a credential management where we confirm the use of a strong password or certificate. We review the key rotation revocation process. Then we have a monitoring and logging, check if the organization use intrusion detection prevention for wireless traffic, evaluate how the logs are stored, analyzed and escalated for the incident response. And finally, we have an incident response where we verify the response procedure there to detect and isolate the rogue access points. So these are some of the practices we have that we follow when you're auditing the wireless network. Okay, so next topic we have is IoT, Internet of Things. As I said, the things which is connected on the internet and you can access from anywhere. So that is basically called as IoT. So if you take an example, we have a camera in the house. We have curtains. We have a window. So all are basically connected with one app. So I log into the app. From there I can able to start the camera, I can open the curtain, I can basically manage the windows. Same with, we have a car, I can operate the car from anywhere. So this is called as a IoT devices. The biggest concern here is availability, because if someone take control over this IoT, then it basically backfire you from a security point of view. So there is a possibility hackers basically try to control these IoT plants or IoT networks to use against your things. So network of smart interconnected devices like sensors, wearable appliance that gather exchange data. So we have a three major risk in the IoT. One is your smartwatch is also example of IoT, right? You can log into the app and you can check the health reports from anywhere, right? Now just imagine if you can able to log into the app, anyone can use the same app to extract your health data. So first is called as a operational risk, like device failure, security breach can disrupt the services. In that case, you will not able to see your health reports. Privacy concern, huge disclosure of data. Network exposure, so compromise of ID devices can basically pivot the attacks into the corporate environment, which is also a biggest concern. So, and that's something we need to overcome. So controls we have is firmware updates. Make sure you update the firmware directly from the vendor website. Whenever you're connecting to device, connect with the password, pin code, associate the device, and then only use the device. When you're sending a data, so let's say example, this is the watch that you're wearing, which is collecting your healthcare data and all that. And then from the cloud, it pulling the data and all that. Make sure the encryption should be there, security should be there. And if you discover any kind of abnormal activity, we should record that. That something is a part of the function. Next thing is basically called as a information security learning. See, when you're talking about information security learning, we have three things. One is called as a awareness. One is called as a education. And one is called as a training. Awareness is something which modify the behavior. Awareness is something which modify the behavior. Is it clear? Education is something modify your career. It's a long term. Awareness is a short term. Education is basically long term. Training is something mid term. Training is something modify the skill. Let's take an example. I am an auditor where I did ISO 27001. I want to upgrade my skill on a system audit. That is why I'm attending a 5 days program of CISA, which basically upskill my profile and update my profile so I can able to perform any activity. Because if you take any example, so this is the project we have. Okay, so we need a special skill to perform this project. That skill demand knowledge, and that knowledge you basically impart from the training. So you attend the training, impart the knowledge, upskill yourself so you can able to perform this task. Is it clear? So attending a CISA program, which is a midterm program, is upskill yourself. You're doing a transition from non-IT to IT where you're attending a 1-year program. That's part of a career education. I was an impression that 8-character password is secure. So I was using 1, 2, 3, 4, 5, 6, 7, 8. So by attending awareness program, I changed the behavior. I got to know that alphanumeric special character should be used in an 8-character. That is called change in the behavior. Is it clear? So that something is there. So security awareness change the user behavior and ensure everyone understand the basic security concept. And ultimate goal of awareness training is to modify the behavior of the people and make them aware about their responsibility. Because there is no tool in this world which can offer you 100% solution. Let's take an example is you are working on the system. You discover some suspicious activity. You are an impression, there is a IT team is there is a security team is there who will take care of this. No, if you discover something, immediately notify. So by attending awareness training, you got to know what is your responsibility. So then in the case of disaster, you can report the breach. That's why we say one of the best success measure of awareness training. If you want to convey the management, we did the great awareness training. The best metrics is increase in the incident report, increase in incident reports, and decrease in a security violation. Decrease in security violation. So increase in the incident report, and decrease in a security violation. What is the meaning is, after completing of this awareness training, more people are reporting incident because now they're getting more visibility. And more they report, we can reduce the violation. So if tomorrow you want to convey the management how the training went, how the awareness training went, this is the best metrics we have. So security awareness, change the user behavior, ensure everyone understands the basic security, and we can have a typical learning like short quiz, brief communication, phishing email exercise and all that. Now security training is provide the instruction on how to perform a security procedures, intermediate, and education basically the high level, long level. So awareness drive the training, training drive the education, which is basically a building upon the previous more advanced skills. That's something we can consider. Is it clear? The question is, what is the benefit? As I said, employee will be held accountable. See, everyone is responsible for security. Management is accountable, but by attending awareness program, they will get to know what they report. Okay. Second is, it serves as a preventative control because regular awareness session remind the user of their responsibilities, reducing the risk of security lapse and all that. And third, more important is employee become more vigilant, spotting unusual activities and all that. By doing awareness program, we can improve the organization overall risk posture by reducing a human error because the weakest link is in the organization is people. By attending awareness program, by conducting awareness program, we can improve this particular defense. And by that, we can also comply with the legal regulatory requirement. Now the question is, what is the condition of successful program? What is the primary factor of a successful information security program is management support. If the keyword say most, management support. Without management support, you can't do anything. Because senior management is the one who endorse and do the endorsement, and they are the one who approve the budget. So allocate budget, resource, allocate for the ongoing training, that is come from the management only. Second is clear security policy. You guide the content of awareness training education program. You align with the regulatory requirement, organization goals. So by this, you're giving clarity. Third is called as a program scope. So you can tailor the content to a specific roles. Like for system administrator, we have a different sessions. For the end user, we can have a different sessions. That's something we can plan. That can be workable. Next important element is called as a motivation engagement. Definitely by using an interactive method like case studies, real life example, you can keep the participant interested, and we can recognize and reward the employee who constantly follow the good practice. And finally, we have one more thing is called continuous improvement. So we can have an ongoing review of training materials, threat intel, user feedback, which is we adopt, and according to that we maintain the relevant things. So that something can be done. The next topic is called as a computer crimes. See, illegal computer crime. One thing we need to understand is when we say computer crime, what is the meaning? So I will use computer to perform crime, or I can use against computer. That is a crime. Like I'm using a computer to perform a crime, that is a computer crime. I'm doing against the computer, that is a computer crime, like targeting a servers and all that. So illegal activities involving computer networks like hacking and all that are called as a computer crime issues. And what is the impact is financial repercussion like frauds or theft can lead to significant monetary loss. Right now you have seen in India, we have a concept of digital arrest. Even in the world level, there's a lot of scam is happening with the elder peoples and all that. If you fail to protect the data, compliance violation is there. Then operation disruptions, attacks can shut down the critical services. Right now you have seen which is happening in a cyber warfare where the one country targeting others and all that, Ukraine, Russia clashes and all that. So that something can be checked. Now motivation for the computer crime is we have a financial gain, we have a revenge, or espionage. Espionage is basically stealing of informations and all that. So these are basically things that we need to address. So we have a different type of malicious user profiles. One is called hackers. They are the one who individual technical skills exploit the systems. It can be white hat and black hat. White hat is basically who know hacking but protect the organization from getting hacked. Black hat is basically doing a hack with the pure disruptive reasons. For example, like I want to earn money, so I become a black hat hacker and I'm hacking for the offensive purpose, want money and all that. After 10 years, I become a very good hacker. I'm now doing social service, so I work for the company. I will think like a hacker and see how they can hack. So I can basically recommend them, this kind of information is there, you should block and all that. So that is called as a white hat. Sometimes insider threats are biggest threat for us. Employer contractors, so they have access to more resources. Now they're not happy with the company decision. So for that, they might try to disrupt the things. They try to share the information with the competitors. Then we have outsiders like cyber criminals, terrorists, organized hacktivists. Hacktivists mean they're hacking for a cause. They have a political cause, they have an economic cause, they have a social cause. So they use a remote attack, social engineering and all that. Then we have a temporary people, the third party users. They accidentally expose data, intentionally abuse access. Then we have an accidental unaware user. They were very good people. They were not aware about they're clicking on some links which is a malicious and all that can trouble the thing. See, hackers, insider, outsider, they have an intention. But accidental or unaware user are not intentionally doing, they're doing unintentionally. They were working on some email, suddenly they saw someone mail and they click on this link. They believe this is some sensitive, good information, but they don't know what is the link behind that. That link will hack the systems and do the things. So it was not intentionally they're doing. Is it clear? So next is called as a different type of attacks. Attacks are very important and you need to have a very good clarity about the different type of attacks. Okay. So first is called as a alteration attack. Alteration is like you're modifying the data. So there is a file is there, we try to modify with the help of virus, we try to modify and we were running a modified file in the system. So that is called as an alteration attack. So attacker tried to hack the system and try to alter the sensitive data, try to alter the critical data. Let's take an example, the financial statement of any company is very important. Based on a financial statement, you invest in the company. So what happen if the virus hack the systems and they alter the financial values? And now it's showing different values. So the people will basically invest in that company based on a financial statements. So that is called as an alteration attack, which basically questions the integrity of the data. Second is called as a DOS attack. So what is DOS attack? DOS attack basically target the availability. How? Let's say example, there is a hacker. He generate a huge traffic against the target to make the target unavailable. Example like, let's take example of the school. So there's a one student who deliberately asking multiple questions with the teacher, make him busy. So other legitimate student who really want to understand, for him the teacher become unavailable because teacher is kept busy with responses of the question. Here the student deliberately want to do that. So same like hacker generating a huge traffic against the server to make him unavailable. But sometimes what happened, from a single system generating a traffic is not enough. So he hacked the multiple systems first. Okay. And from there he launched the attack, and this is basically called as a DDoS attack. And when he compromising the multiple system to generate a traffic, that is called as a botnets. Is it clear? That's there. Then we have a social engineering attack. Social engineering is like, manipulating people into revealing the confidential information. Someone basically used my name and called my family, hey, this is Prabh friend, Prabh in trouble and he needs some cash. So here, based on a trust of the name, they're trying to collect the information from a family. So that is called as a social engineering, where we manipulate the people into revealing the confidential information like phishing email, fake support call, impersonating employee. Nowadays we have a digital arrest. So that is a perfect example of that actually, if you take the context. Okay. Next is called as a malware. So when we're talking about malware, we have a malicious softwares like virus, worm, Trojan, ransomware, targeting a system with the objective of stealing data, damage the system, encrypt the files. And then finally we have a spam and email exploit where we send a bulk message to deliver the malware or phishing content. So these are basically the common attack vectors we have by which we target the system. Then we have a Smurf attack, very, very important. Smurf attack is a DDoS attack. So if you go by the description, it says that it exploit the ICMP echo request by sending a spoof packet to broadcast address. What is the meaning is, suppose this is my system A. A is the attacker. And his target is basically B. His target is B, or you can say a victim. And here we have 1,000 hosts. So A spoof the B IP and send a broadcast request to this 1,000 host, ICMP request. Ping, ping any system, that's called ICMP echo request. ICMP echo request. So these 1,000 IPs reply back to the B system, because by end of the day, in the source IP, it was mentioned a victim IP and destination was 1,000 IP. So these 1,000 IP reply to source, and source was the B. So all the traffic is coming on the B. So B is basically flooded with multiple requests. That is called a Smurf attack. Ping flood mean we directly sending a ICMP echo request to overflow the memory. That is called as a ping. In ping also, one thing is that the ICMP echo request, the size is bigger than normal size. Next is basically called as a synflare attack. Synflare attack, where we basically send the multiple sync to overflow the system. How? Let me explain you. So if you go by the description, it say abuse the TCP handshake by sending sync packet without completing a process and keep the server in limbo. What is the meaning? We have a system A. Its IP address is 1.1.1.1. We have a system B. Its IP address is basically 1.1.2. A basically send the SYN packet. In the source, in the SYN, he doesn't mention 1.1. He mentioned some IP called 2.1.1, which is not even exist in the network. So he basically send the SYN packet. So he keep the SYN packet in the memory for a 70 seconds. Why? Because he also send the SYNAC. If we get acknowledgement of his SYN, then only he will remove. But as I said, the IP doesn't exist, so there's no reply. So B is kept waiting for his reply of the SYN what he sent. And he will maximum wait for 70 seconds. So meantime, what happened? Attacker sending a multiple SYN request, and memory is basically filled with the fake SYN request. So further, it will not be in the position to handle any connection. So that is called as a synflare attack. So if any legitimate user want to access the website, first he send the SYN packet, B is not in the condition to accept a new connection. So that is basically called as a synflare attack. Last is called as a teardrop attack. What is teardrop attack? So we have a system A and we have a system B. Normally, if I want to send data, this is the data format we have: hi, my, name, CISA. So data is divided into fragment 1, 2, 3, 4, 5. So I send the first packet, and I told the next packet will. So first packet is 1, 2, 3. It means HIM. So next, so be expecting the next will be 3 to 6. But I basically send the 7 to 9. Then I send the 2 to 1. Then I send the 3 to 4. So in a very unsequenced manner. It is same like he said, hey guys, tomorrow I'm going to start a session and tomorrow I'm going to cover domain 4. And suddenly I started domain 3. Then after 2 hours, I start domain 2. So it is basically overflow the memory. It is same like, I will give you, okay. So if you're looking for a CISA shortcut, domain 1, domain 2, you can refer from review manual. Domain 3, 4, 5, you can refer my videos. Okay, domain 1, domain 2, you can refer my videos. 3, 4, 5, you can refer the manual. Sorry, 4, 5, you can refer the manual. So here what happened, every time I'm changing a statement, so your brain will basically flood. Your brain get crashed. So same thing happen here, your memory get crashed, and it is the target of the attackers, which is basically called as a teardrop attack. So it's sending a fragmented IP packets that crash or freeze a system with resemble incorrectly. That something is part of the DOS attack. We also have other attacks like eavesdropping. So two systems are communicating with each other. So we are intercepting the information in two parties. That is called as a eavesdropping. Second is called as a phishing attack, where we're sending a phishing emails. If you're targeting a specific companies, then it's called spear phishing. If you're targeting a specific management of the company, that is called as a whaling. Flooding is a part of a DOS attack where we overwhelm network or system resource with excessive traffic, which lead to the DOS and crash the system and directly impact the availability. So countermeasure is we need to have a redundant systems and we need to monitor such kind of a connections. Next is basically called as an interrupt attack, where we temporarily disable or corrupt the system OS functionality, and it basically cause the system failure, downtime, or partial service loss. So these are some of the attacks we have, which is very commonly followed in the system. Next is basically called as a juice jacking. Now what is juice jacking? It is occur when devices plug into malicious USB port. So let's say example, you want to charge your phone. So you connect the USB port to the any terminal and all that. What if the terminal is basically pulling all the data from your device? See, this is the terminal we have in the airport and they're giving you the power connection. So you connect your USB, but that terminal is pulling all the information from your phone. So that is called as a juice jacking. So it allows the malware injection or data theft silent during a charge. Then man in the middle attack, like we have a system A and we have a system B. Someone is intercepting your A and B data passively. Someone is listening to your data passively. They're not modifying, but passively listening to the data. That is called as a MITM attack. But it is same like, you're speaking to your girlfriend, you're speaking to your boyfriend, but on the other room, your parents pick the call and passively listening what they're chatting, what you're communicating. So that is called as a man in the middle attack. But masquerading is basically where someone is impersonating me a Prabh and speaking to my friend to gain access. That is called as a masquerading. Ultimate goal is to gain unauthorized access and modifying that message. So these are the common cyber attacks we have that we follow in the organization. Next topic is called as a malware. It's another important topic. We have a different type of malwares. Malwares are the one which damages the system. Malware is the one which slow down the system. So that is called as a malware. The first malware we're going to discuss is ransomware. So we have a system A, which is operated by hacker, and we have a system B, which is my target. Hacker hack the system, use the public key to encrypt the data and keep the private key with him, and then against that ask for the ransom. Because in the ransomware attack, they hack, they encrypt the data and kept the key with them. So they actually use public key to encrypt and they keep the private key with them. So the person has to release the money to get the key so he can decrypt the data. So that is called ransomware. The only solution in the ransomware is effective backup. If the data is encrypted, you can, with the help backup, you can restore the last version. Second is called as a worm. What is worm is, we have a system A, we have a system B. System A infected with a worm. It replicates automatically from system A to system B if you ping the system. That is called as a worm. The difference in worm and spyware, worm and virus is that if system A is infected with the worm, B ping the system worm automatically replicate to B. So it automatically get replicate within a network. But in the case of virus, if system is infected with the virus, I plug the pen drive, I copy the file. Along with that, virus also copied into the system. Then I insert the pen drive in the B, then only virus will be active. Virus required the blood cells. Spyware we install so we can record the keystroke activities of the system. So whatever you're typing and all that we can capture. We also have another malware which is called as a Trojan. Now what is Trojan is, I convince the B to install Trojan. Now what happened when the B installed Trojan? What happened in Trojan? Trojan doesn't slow down the system. It opened the dynamic port. Then I gain access to the system through that particular port without the consent. That is called as a Trojan. And spyware and keyloggers are the same thing. So ultimate goal of all these things is to disrupt the systems. Okay. So propagation and the vector of spreading this is by email attachment, or you connect with the website. From the website you download the virus. I give the pen drive in, that virus is there, or with the help of vulnerabilities. So we are using some countermeasure. The first is called as an anti-malware. Installing anti-malware, they can able to detect the virus and everything. So keep the signature up to date, because if it is not updated, the new virus can easily replicate. Second is system hardening is there, where we restrict the user privilege, used host-based firewall, disable the unnecessary services. Third is safe computing practice, avoid unknown links, attachment, use strong passwords, and regularly patching your systems. That is something is a best practices we have to follow. Along with that, when you handle any removable media, this is the exam question. Okay, what is the first step when you handle removable media? So whenever you handle removable media, first scan and then connect. Second is limit the auto run, disable the automatic execution, because sometimes what happens when you connect the pen drive, it has an auto mount, right? So disable the auto run, and always give proper attention to the pen drives and all that, because small in nature, it is easy for us to replicate things and effectively. So protect the device from tampering or theft. That is the most important practice we have to follow. So we are using different kind of anti-malware solutions. So first is called signature based. So what happens is, we have an antivirus running. It maintains the signature of the database. So whenever any file comes, they check the signature of the file and compare again the signature database. If it's matched, it is a virus. But one disadvantage is that it doesn't maintain the up-to-date new virus and all that. Second is based on a behavior it detect, like how it behave, how it running. So that is basically called as a heuristic behavior-based analysis, which look for the abnormal activity and all that. Third is called as a real-time scanning, where we check the file as they are open. Or sometimes what happen is, we have a schedule scan, where we have a periodic compliance check, comprehensive check of the systems. That something is a best practices we have. So as I said, reliability we have to look for, continuous update required, vendor regularly release a new signatures. Sometime virus detect as a virus, but it is not a virus. And that is mostly you have seen in the heuristic or behavior base. And when you do the when you do the aggressive scans and all that, it impact the performance. So that something is there. So when you're talking about ransomware, you need to know the ransomware phases. The first step is we infect the system and we gain access. Then we encrypt the file. Then attacker display the note demanding a ransom. One thing always remember, By end of the day, the only solution in the ransomware is basically backup. So use a secure network, a regular backup of the system, store backup offline in a read-only location. So if your current system is infected, from the alternate location, we can retrieve the data. Up-to-date patches, limit the privilege. So if user account is compromised also, it has a limited impact. And more important, provide the employee about the security updates and everything. So what is the countermeasure? The countermeasure is quarantine. If you find the system is infected with ransomware, isolate a system, not power off, network, remove the network cable, disable the shared folder or map drives that ransomware could basically spread. If feasible, wipe the infected systems and restore the clean data. And in some regulatory requirement, you have to report the breach. Like in GDPR, we have a 72 hours. In India, we have a 6 hours. So in US, we also have a regulatory guideline to report these things. It's very important. So these are the practices you have to follow when you're dealing with the incident. Okay, so next topic is called as attacks. Overall, we have a two type of attacks. One is called passive attack, where attacker quietly observe, intercept the traffic. Let's say example, we have a system A and we have a system B. So there is an attacker who passively observe what A is sending to B and B is sending to A. He will not react or she will not react. That is called passive attack. Active attack is basically like A directly targeting B by sending a DOS, doing a brute force, interacting directly with the system. That is called active attack. So question can be asked is in which condition you have a high probability to getting caught. So answer is active because you're directly interacting, you're directly disrupting. So your eavesdropping, traffic analysis are called as a passive attack, where the DOS and DDoS attacks, brute force directly on the username password, that is called as a active attack. So active attack like gaining high level access to modify the critical data, then alter the files, programs to disrupt the operations, launching an attack to make the resource unavailable, and delivering the malware via attachment or malicious website. So that is a live example of the active attack. Now we have a lot of risk to the organizations when these attacks are initiated. The first is called as exposure of sensitive data like intellectual property, customer records, or financial information can be disclosed. Because hacker has a mindset and hacker want to hack the systems by doing active and passive attack, and goal is to grab the intellectual property, customer records, financial informations, then disrupting the key services, reducing the availability, and more important is basically creating a reputational damage. So countermeasure is install the firewall, IDS, MFA, secure password policies for strong authentication, regularly patch the systems, employ trainings. That's something done. But how we actually do this? We also as a company do this assessment just to check is my company is vulnerable for such kind of an attacks, right? So for that we do the assessment and audits. So what is assessment? Assessment is a systematic review of security controls, policies to identify vulnerability threats. On the other side, audit is a formal review process comparing your current security practice. In layman term, you can say VAPT part of an assessment, like series of assessment we're doing against testing of the controls and everything. That is called as an assessment. But checking absence and presence of document, reviewing the document, checking the governance, that is called as an audit. So the focus of security assessment, evaluate the effectiveness of the existing controls, align with the risk tolerance. On the other side, security audit is basically checking the compliance, GDPR policies and everything. In security assessment deliverables, we have a detailed report of finding, risk, recommendations, and in security audit, auditor opinion for the certification and level of compliance. You can say security assessment is broad, risk-based approach to improve the overall security posture, whereas a security audit is a formal checklist based on the specific benchmark or framework. And I will explain you with a layman example. Let's say example, I'm doing an audit based on 27001. My assessment, my checking is based on a control. So that is called security audit. But I'm exploiting a system, finding a vulnerability in the systems. That is basically called as an assessment where I'm not following any checklist. That's why it's called broad. So as one of the example of assessment is pen testing. Now what is pen testing? We have a system A, which is run by a penetration tester. And his goal is to basically assess these applications. So we have one website, we have a database, and we have other application. So what is penetration testing? So penetration testing is all about identifying the vulnerability in the system. That's the one thing. Then exploit the vulnerability to gain access to the system. Understood? So that is basically called as a pen testing. See, identifying vulnerability is the vulnerability assessment. It is same like knocking a door, by which you're analyzing the quality and all that. That is called VA. But breaking the door and getting into the house, that's called PT. So not every company go for PT, but every company go for VA because that closely align with the patch management process. So PT include on the network level application, physical, social engineering test, and we have an approach of doing that. So I have hired a pen tester and I have shared zero information about with the tester. So that is called black box. I have shared the complete information, source code, internal details. We just need to exploit that. That is called as a white box. I repeat again, black box mean I told the pen tester nothing about the company. I only told that, okay, company has a website. That's it. So he will discover the actual website, discover the rest of the informations, gathering informations, and then do the testing. That is called black box, where I have a zero information share with the tester. In white box, I have shared the complete information. This is the server, this is the vulnerability, this is the configuration. So your goal is to exploit the vulnerability to gain access to the system. Then third is basically called as a gray box. Gray box is a combination black box and white box. It means we have given the better information than white box. Sorry, better information than the black box and lower information than the white box. It means we share the IP configuration. They have to find the vulnerability and they need to exploit that. So that is basically called as a gray box. So that is an approach we have. So outcome of the pen testing is to provide detailed report and to discover the vulnerability, proof of concepts, recommendation, and it provide insight into defensive gaps and response readiness. That's something we are taking care. Now, when we doing this assessment, it is done by the three type of team. Now, please listen this carefully. The first team is called as a blue team. They are the SOC team. They are the one who are the defenders. They act like they focus on defense, protecting the organization system. Pen tester is part of a red team who emulate the adversaries. Adversary mean hackers and all that. They emulate the adversaries to test and challenge the defense. Purple team is act like a bridge between the blue team and red team. See, blue team has a thought process how to protect. Red team has a thought process how to exploit. So at one point of time with red team find the vulnerability and they're giving a recommendation. Their thought process is not like a blue team. So sometimes blue team will argue on that. So purple team will bridge the gap. So they are act like a subject matter expert to explain the blue team how they exploit by the red team, and they explain the red team what is the challenge they face by blue team. So they bring as a balance approach. Is it clear? So that is called as a purple team. So blue team is the one who are basically part of a SOC and all that. Their goal is to protect the organization from attacks, hunt for attacks and try to block. Their scope is basically organization-wide monitoring, incident response, threat mitigations, and they do the monitoring with the help of EDR, SIEM, logs and all that, and real-time ongoing defense to keep the threat at bay. Red team is the one who does the full-scale pen testing or attack simulations. They simulate the sophisticated offensive technique. They perform the pen testing. They think like, okay, how the competitors got attacked, and they try to mimic the same attack pattern in our organization to check whether our organization is vulnerable for things. That's where they help you to identify vulnerabilities and everything. But purple team work with blue team and red team, bridge the gap between red and blue team, collaborate synergies there, whether red team test, blue team respond, purple is basically refine that. And they combine the both approach to provide the effective functions. So that is the goal we have. Now we have a different type of security testing technique. Now please give attention to this. This is a very important topic. So these are the different type of approach we have. Okay, now listen carefully. The black box, white box, and gray box is called as a type of knowledge you get. But how you use this knowledge and how you perform the testing, we have a three type of testing. Actually, I'm ignoring right now this. Actually, we have a three type of testing: SAST, DAST, or IAST. And listen carefully. SAST is basically mean, let's say example, this is the website. This is the website, and this website is basically running in the system. So as a pen tester, I'm not going to test against this running site. I'm not going to test anything against the running application. I'm not doing anything. I will just check the source code of the application. I will read the source code. I'll identify the bugs in the source code without executing anything on the website. I'm just reading a code, identifying things and all. That is called as a static application security testing. So whenever in the exam, question talking about analyzing a source code, review the source code, line by line reading the code, white box testing, answer is static testing. Because here we analyze the source code or binary without executing the program. And here the focus is to identify things as early as possible. So one advantage is that you can able to find the coding flaws before deployment, and the last stage where we can do this in a development stage. But disadvantage is that it sometimes produces a false positive, required access to the source code. Now second is called as a DAST, Dynamic Application Security Testing. So website is running, We do the test against the running site and see how they basically reply to me, analyze the response and everything. So I'm doing a test against the running application. Okay, normally like you enter the URL in your VAPT tools, the tool will automatically scan scripts against the running side, how you get a reply, you analyze all the response. That is basically called as a DAST, Dynamic Application Security Testing, where you test, the test is running an application from outside simulating real world attacks. So we look for the runtime vulnerabilities, cross-site scripting. We detect issues in a live environment, including a configuration error, but limited visibility into the code. Dedicatedly testing the mobile application is called mobile application security testing. It's up to you how you want to test. You want to test against the running application, then it's a DAST. You're reading a source code, that is called as a SAST. Okay. IAST is a new concept. Now IAST is the combination of the SAST or DAST. Now what is the meaning? The website is running. There is a hook we have in the website. And here we have a screen. So when someone is trying to do any kind of a modification in the website, and that modification modifying the source code and anything in real time, I want a data. See, until unless you don't perform SAS, you can't find the bug. Until unless you don't perform DAS, you can't find the bug. But in IAST, it is happening in real time. So there is a hook was integrated in the website. And whenever any attempt has been done on the running side to modify the behavior and everything, in real time, we get the data. That's why it's called, the focus is provide the real time feedback. Definitely we need a code access because we need to integrate the module. It more accurate detections, few false positives than SAS or DAS, but required instrumentation in the application environment can impact the performance because there's a hook was integrated in the module. So that is basically called as a IAST. So combination is, let's say example, company has given me a black box, zero information. So I can do only DAST. Company given me source code, then it's the approach I'm using is SAST. Combination I can do in the real time. I release the application real time. I want the monitoring to be done. So I will do basically the IST. So IST is doing a testing also in real time. We get a data also. Is it clear? That's why it's a combination. So next topic is called as a SOC, Security Operations Center. SOC in the organization used to monitor the threats, monitor the incident, monitor the issues, and try to reduce the impact. So they do common activities like they do network and endpoint monitoring by using a SIEM, IDS, logs to spot the anomaly. Anomalies are called as an abnormal activity. Then we have a team which does to respond to the incidents. They investigate the alerts, reduce the impact, which is called contain the breach, and recover the affected systems. We're going to discuss what is SIEM in the further slide, don't worry. Third, they also track and remediate the software patches, misconfigurations, look for the exploits, and maintain the up-to-date list of hardware, software, critical data so they can able to patch things effectively. On regular basis, we need to report the incidents, regulatory requirements. So SOC head, drive all those functions. That's something you can take the parameter. Now, another important thing we will look for is regularly update the systems, gather, analyze the threat data to anticipate the future attacks. Now, what is threat intel? Let me explain you. See, first understand a intel concept. Threat, right? Threat is something which perform dynamically and all that. Like someone is attacking me, that is a threat. When I go for CISA exam, I don't know what question can be asked. That is a threat. So threat is very dynamic in nature. Threat is triggered from three factors. MOM, mean. O stand for opportunity and M stand for motive. Mean is called as a method also. See, now we are trying to patch a vulnerability because that is an opportunity for him. And we cannot control his motivation, but we try to predict what is the method he use. So let's say example, we have a three house, house 1, house 2, house 3. We have installed a very strong physical door. Okay, the door is there. So there is a one person knock the door. He say, hey, I'm from NGO. Based on a trust, we open the door and that person is basically attack us. Even we have a strong security control, physical control, but it doesn't work here because we are unable to predict the threat parameter. Same thing happened on the house 2. The person knocked the door. Hey, I'm from NGO. Based on a trust, we open the door. He attacked that person. Third person got the data of both the house, which combined that become a information. On that, he applies intel. Okay, at 7:30 evening, he will come to my house also, knock the door. Before he knock, he called the police. So that is what. So what kind of an attack is going to be happen on my organization? I'm predicting on an advanced level. Okay, how? We have a companies who basically provide you the feed. They provide you the intel, and that is called as a threat intel. So we gather, analyze the threat data. So proactively, we can protect the organization from all the attacks. Is it clear? Like I got to know people are using a darknet to collect my information. So I'm thinking like an attacker. I went to darknet and I tried to remove all my data pointers. So that is something which I'm doing here. So the key responsibility of the SOC is to predict the threats proactively so we can materialize the impact. We do 24/7 monitoring to detect any issues, and we do collaboration with the multiple team just to improve our security effectiveness and all. There's a dedicated video I made on threat intel. If you want, you can check that. So benefit is centralized security, single hub for incident management, log correlations. SOC staff can quickly contain the threats, reducing damage. And we can able to improve the security postures by ongoing analysis to identify weakness and guide the strategic security investments. That something can be done. Now in the SOC, the most important part is logs, because logs give you the story, what is happened, so that you can able to improve your action plan. So the purpose of logs is to identify the normal behaviors, abnormal behaviors, intrusions and everything. And logs are the gold mine information for us. We have a different type of logs: system logs, application logs, network traffic data, secure device alerts. One thing is missing, which is called security logs also. In every desktop window-based system, we have a security logs. Now, what is security log? Security log capture your password attempts. You typing a wrong password, that captured in the security log. You type the right password, successful login, that captured in the security log. You try to access the file and folder for which you don't have a permission, that captured in the security logs. On the other side, system logs record your service failures, application log record your application events, network traffic data basically capture the network activities, what is happening in the network. So all those things are basically captured here. Okay. And by using these logs, so benefit is basically non-repudiation, because in the logs we can capture the IP. If my friend is doing an attack on me, his IP was recorded in my system logs. So can he deny later? No. So non-repudiation has been set up. Second is with the logs, we can respond to the incident. We know which IP I want to block. And third, we can comply with the legal regulatory requirement. But challenge is when you're receiving excessive logs and all that become a challenge. So I'm looking for an automation to correlate and everything. That's why we introduce a concept of SIEM. Second thing is that what are the logs we have collecting? Sometimes we have to retain the logs because of legal regulatory requirement. Sometimes it's a business requirement. Sometimes for the operational reason, we retain the logs. So that is basically there, but it comes with the cost, it comes with the overburden and all that. Now, if I want to predict, I want to analyze what kind of an attack can be possible in my system, I install the dummy system, I install the fake system. So here that is called as a honeypot. Let's say example, this is your DMZ, demilitarized zone. So in the DMZ, I keep those systems, which is a public facing system. So one of the system I install a fake system. So attacker basically doing an attack on the fake system. With this assumption, it's a real system. So we learn from this attack and try to improve the defense. That is called honeypot. Honeypot is two types: high interaction and low interaction. High interaction, we configure real system with real data. Low interaction is basically we emulate the basic service and we configure the virtual local systems and all that. And creating a, if you want to create a complete network itself, then it is basically called as a honeynet. It is called as a honeynet. So it provides the proactive intel on attack tactics and be carefully to isolate to avoid risk to the production network. So here the countermeasure we have is the risk is like, when you're capturing attacker data, could have a legal implication. Some countries you need to take a permission before installing a honeypot. Second is attacker may ignore the honeypot and target the production system. And more important, it required the monitoring to us systems and all that. That's why honeypot is part of an enticement. We always call honeypot as an enticement. Enticement. Okay, it is an enticement, not a entrapment. We are not installing a honeypot to create a trap. We are creating a honeypot to learn the attacks. Is it clear? So tomorrow you install the honeypot and then you telling the attacker why you're doing an attack on me. No. You install the honeypot because you want to understand what kind of an attack is happening so that you can able to improve your defensive systems. That is very important for us. So logs is very important. So log is basically record who accessed, what he did, when he did. So you can support the non-repudiation. It helps you detect the unauthorized suspicious activity. So we already discussed regular reasons and all that. We retain the logs. It is very important to audit the logs in detail. So large volume can strain budget. So organization must find the right balance of detail versus retention period. So we have a log clipping policy and all that. What is log clipping policy? We don't need to start generating a log from the day one. Is it clear? We are not generating a logs from the day one. So we have to see how you can balance, optimize and all that. That's something can be done. Then SIEM solutions can be expensive but provide the real-time data. But sometimes what happen is security admin responds to the analyzing logs. So too much logs create an issue. So better escalate to management, notify the law enforcement if you think it's required for the functions. It is very important. We need to protect the logs. Okay. Because logs must be protected from unauthorized access and modification to remain reliable. Because if logs get altered, you cannot able to do the investigation also. So if attacker can alter the log, they can erase the evidence because that is the only source you have by which you can able to investigate. Understood? So it's very important to protect the log from unauthorized modification because logs create a story. Logs is the only source you submit to the court as an evidence. So how we can able to protect the logs? The first we use a centralized log storage. All the logs will go to the one centralized server. And that server is called as a log server. Is it clear? In my previous video, I've explained that. Make sure whatever the logs, wherever the logs has been stored, it should be protect with the principle of least privilege. That is called access control and it should have a right protection. Make sure if anyone want to access, it should be access based on ID base. So configure login to avoid recording non-essentials and everything. Only capture relevant data. Next, log policy. Log policy basically talk about how to retain the logs, how to take a backup, how long we need to keep. Then secure log transfer. So physically protect the storage media using a secure protocol like TLS to protect the data during a transport. That's something we can consider. Protect the archive logs. Use the methods like creating a message digest, encrypting logs, securing archival media. That's something we can consider. And finally, we have a concept called implement log disposal control. So ensure the logs are safely destroyed when no longer needed and using a media destruction method to eliminate the data remnants. That's something we can do that. The next topic is called as a SIEM. So what is SIEM? SIEM is stand for Security Information Event Management. So let's take an example. This is my firewall. Okay. Here we have a SIEM, Security Information Event Management. And it is basically connected with the switch. So we have a system A, we have a system B, and we have a system C, and we have a system D. Okay. So now what happened is there is IP which is called as a 1.1.1.1 was able to bypass the firewall. So firewall logs goes to SIEM. It attacks system A, B, C, D. That logs also go to the SIEM. So now what happened? SIEM is a server where we keep logs. Traditionally, the challenge is A using a Windows, B using a Linux, C using a Mac. Different system generating a log in a different format. This firewall is also using their own firmware in which it's generating a log. So this is also generating a log in their respective format. So the biggest challenge for us traditionally to have a log management system is converting a log and understanding a log and everything. So to automate the conversion, automate the correlation, automate the aggregation, that is done with the help of SIEM, because SIEM has a one feature which is called as a data analytics. So now what happened? The first thing what SIEM does is collect the data. Second step, what it does, it normalize. Normalize means converting log into common format. Third, we aggregate. And fourth, we try to correlate. What is the meaning is IP called 1.1 able to bypass the firewall. It went to the SIEM. ABC data 1.1 went to SIEM. So first step is collect the data, normalize into common format, aggregate about 1.1 and then try to correlate how the 1.1 able to bypass the firewall went to ABCD as per the timestamp. So we can able to resolve, we can respond to the actions immediately. And that is basically called as a SIEM. So they operate based on rule base or correlation base by which we, so in one dashboard, we can have a complete visibility. So SIEM collect the historical log data from various security tools for analysis and reporting, and SEM monitor the system in real time. So that kind of feature we get here. So what are the features of SIEM? The first feature is policies. We can create policies, what to collect. So we can create a profile that defines the system behavior under the normal incident conditions. They store the technical information about non-vulnerabilities, log message interpretations, and all that. The third is called log data management. So it has a pools log information for various sources across the network. So it enables the real-time analysis for the log and network flow data. Notification alert, as I said, we can recognize a pattern of malicious behavior. We can raise the alerts that are analyzed by security analysts to refine the future criteria. And more important, we can use packet capture traffic flow to reveal the malicious files and enhance the overall infrastructure insight. So we have one dashboard from where we have visibility. We can also track the incidents and everything, and it can also provide the workflow. So these are the benefits we get when we go for the SIEM. So next topic we have is incident response process. Incident response is a corrective control. Whenever any incident happen, what is the reason of incident? Because there is a failure of preventive control, detective control. System was infected with a virus. Hacker basically hack into the system. So we need a process in place by which we should respond to the incident. Ultimate goal of incident response is to reduce the impact. So we have a steps in this process. So the first step is preparation. Now in the preparation, what happens is we define the policies, we develop the policies, document the roles and responsibilities. So policies comes here, roles and responsibilities comes here, SOP comes here. We trained the team, SOC team and everything, and we maintain the notifications and everything. That is called as a preparation. Now there is a user A. He working on the system. He discovered some suspicious activity. Okay. He report this particular issue to the help desk. Help desk report this issue to the SOC. SOC basically asks the multiple questions. This entire activity is called as a detection and analysis. So detection is basically where we deploy the robust monitoring solutions like IDS, antivirus to detect the incident as quickly as possible. And as I said, user also discovers some suspicious activity. So he report this issue so that, the team will ask the questions and confirm. So first thing is that in detection is to confirm the incident, because not necessarily every incident has been reported as a true incident. Then we analyze. Once we confirm, we isolate a system immediately. That is part of a containment. So containment is basically mean we decide on the action like shutting down the system, disconnecting. So ultimate goal of containment is limit the impact. If the system is already infected or hacker hack access to the system, from there he tried to hack. So we isolate a system immediately. So that is called as a containment. Then next is called as a eradication. Eradication is basically mean delete the malicious code, disable the account, delete the file. That is called as a eradication. Removing a threat from a system is called eradication. Then restore the system back to the production. Okay. Rebuilding the system, replacing the compromised file, tightening the parameter, that is called recovery. And then we learn the lesson. What is the lesson we have learned from there? How can we improve this particular process? How to improve the next time it should not be happen again. So that is basically part of a post incident activity. So we're going to discuss each and every step again in detail, because I have a table here which give you the great visibility. You can see the first step is preparation, where we define the reporting structure. We develop the incident response policy, SOP, communication. We train the response team to establish the call notification thing. Then second step is called detection, where we deploy the monitoring tool IDS, IPS. We use manuals, automate method to determine the scope and impact of the incident. And it is a stage where we confirm the incident. Okay. Next is called as a containment. Containment prevent the spread, like isolate the infected system. Eradication, remove the malware. And then we do the clean installation, restore the system back to the production. And finally, we have a post-incident activity where we'll have a lesson run. We analyze the data to identify root cause, why this happened, how this happened, just to make sure it should not be happen again. So we're looking for the permanent solutions. And according to that, we update the policies and everything. So you can say root cause analysis we do in the post-incident activity, just to make sure the similar activity, similar practice should not be happen in the future. Is it clear? So that is basically called as a post-incident activity. Next is basically called as a incident response plan. See, it is always whatever the repetitive task we have, we can automate that. So by this, we can combine the tool and process to reduce the manual effort. We leverage a template and playbook. Playbook is like a rule book. We use a agile, we use a customizable playbook that outline the roles and responsibility. We can have a centralized incident response initiatives. Okay, so we can gather data from all the security tools into the single accessible resource and everything. We can test the plan regularly. We conduct the exercise drills to evaluate the effectiveness. Okay, the step 1 is this, step 2 is this. Is it working practically? We standardize the incident response process. We establish the uniform procedure to simplify the training. You know, in my absence, someone can follow the procedure, respond to the incident. If that is not available, if new person is joining, is easy for me to do the KT. Then obtain the executive buy-in because we need a security supports and all that. We document the critical assets, and we also have a communication plan. So that's why nowadays what happened, we're using a concept of SOAR, security, orchestration, and automation. So initially what happened, any incident happened, the SIEM detect, then manually human go and resolve and isolate the system. But now what happened is all the solutions are orchestrated. You know, orchestra, the band orchestra, where the multiple instruments are working together. So here the SIEM, firewall, everything is orchestrated. So we connect the different security tool to streamline and harmonize the security process. And then we automate this. And then according to we respond to that. So biggest reason of using a SOAR is to reduce the human effort and detect incident, respond to the incident as early as possible. So collection of technologies that integrate input from a security monitor tool and automatically respond to the security events, that is called as a SOAR. So benefit of SOAR is security visibility. We can provide dashboard reporting for comprehensive insights. Second is reduce the security cost because we can streamline the operations and reduce the labor through automations. And third is called as a improve efficiency and effectiveness. We have a fast and more accurate threat response and incident resolution. That something is advantage we get. Next is basically called as a phases of computer forensics. See, if any incident happen, we need to investigate why this happened and all that, right? So we can able to resolve, we can able to challenge. So that is called as a computer forensic process of investigating a computer incident to come to the conclusion who did this. So we can able to present to the code. That is called as a computer forensics. So first response is immediately engage the computer forensic team when the incident has been reported, and actions depending upon the incident nature to secure the scene. The first is that report and seize the scene. Second is called search and seizure. For forensic team, we'll basically search the involved device that collect data. So let's take example is this was the server was hacked by the hacker. So incident response team isolate the system. And forensic team is basically first make a bit by bit image of the system. Bit by bit image considered as one of the most accurate form of system state, because we never do the investigation on the live system. We take the photo picture of the incident area, and then we basically take the memory data. Then we take the ghost image of the system and deploy the copy of the system there and do the investigation on that. We never do the investigation live systems. That is the practice we actually follow. Now, next is basically called as a evidence collections. So I missed that. Evidence collection is where we collect the data using a method and we gather informations. Whatever the collection we happen, one more important thing which is missing here is it is called as a evidence security. So store collected evidence is secure and in control environment to prevent the contamination. So we need to make sure it should be protected from unauthorized access. We also need to see what is the data acquisition process you are using. That is another important thing. So we retrieve all the informations. We use a proper procedure. Whatever the image we store in a write blocker. There is a concept called as a write blocker. Write blocker. So whatever the data we have, we can keep it in write blocker. So it can prevent, it can avoid altering data and maintain the integrity. And what data we have, we do the analysis of the data where we identify, examine the data using the extracting data, and we transform the collected data into the evidence because we need to present the data in the court. Then we have a next concept which is called as a evidence assessment. We evaluate the extract evidence against the specific to the reported, ensure the evidence directly correlate, and document report. And we also have a concept called testimony. where we qualified forensic expert testify to confirm the collected evidence is reliable and admissible in the court. Now we have a different type of investigation actually. For your information, we have a different type of investigation. When we're doing an investigation of a database, that is called database forensics, where we retrieve examination data or metadata from database. So in this, they're required to have unrestricted access to organization database. When you're doing an email forensic, you analyze the email content and all that. So we require access to both attacker and victim email address. When you're doing the mobile forensic, you retrieving the analysis of the text data from data, and it is biggest challenge for us to retrieve the firmware data of mobile. But in this case, we need a physical access to the device. Then we have a memory forensic where we examine data which is stored in the memory cache. So whenever we're doing investigation on live systems and all that, live analysis, last recent data, who accessed my last recent data, we start with the memory analysis only first. We never shut down the system, because if you shut down the system, you will lose the memory data. So we use a live analysis technique to capture the real-time memory activity. Then we have a network forensic where we're monitoring and capturing, analyzing a network traffic, where we identify the abnormal. And then we have a malware analysis to identify the author of the malware, who did that, what is the context and everything. That is something, is a process we follow. So question is, what is the thing? So we use acquisition tool, like when you obtain the evidence, we do bit by bit image and ensure the evidence integrity for later. And we also have additional evidence back, where we have physical containers in which we keep the evidence with the tags, back files, to maintain a chain of custody. Chain of custody mean who obtained the evidence. Let's say example, I'm the one who obtained the evidence from a crime scene at 7:30 a.m. I hand over the evidence to my friend at 8:30, and this was the hash value. He hand over the evidence to the advocate 9 o'clock, and this is the hash value. So this is the file we submit in the court. So that is called as a chain of custody. We also have a chain of evidence, the sequence in which we obtain the evidence. Like first I obtain the evidence from the firewall, then I obtain the evidence from the system. So that's called chain of evidence, the sequence in which we obtain the evidence. But who obtained the evidence and what is the evidence handling methodology we have, that is basically come under the chain of custody. So software that examine the bitstream image, generate a file listing, detect anomalies. So we have a tools like TrueCrypt and steganography analysis, because the biggest challenge for us to check the data in the images. Process of hiding data in the image is called steganography. So we have to really check, is this file has any other files and all that. And we also use a file recovery tools to recover the data. See, chain of custody is very important. Okay, so we need to preserve the evidence, because by the evidence only we can able to prove someone's guilty. So never ever do the analysis on the live evidence. We always do the analysis on the copy of the evidence. And there is a detailed log must record who accessed the evidence, when and what. Because when you start any investigation, the first thing we need to create a log. What you're going to collect, who you're going to collect, that's a very important thing. Because it ensures the evidence can withstand the legal scrutiny. And the best practice, we use a write blocking tool to prevent modification during a data acquisition, and we maintain the strict documentation to prove the evidence integrity. So what is the best practices? The first is that prevent contamination. So preserve the crime scene by taking a forensic image, not working on the original data. And most important, maintain the environmental control to prevent all the alterations and all that. Second is establish a chain of custody. Document every transfer, access, handling of evidence. Okay, so ensure all evidence transactions are recorded to avoid gaps in the chain of custody. That's a very important part you need to consider. Next is implement the tamper detection, like you can create a cryptography hash. Okay, then secure storage device. So we can physically store device using a digital evidences. Okay, that something is there. Use a write block softwares. So by this, we can able to prevent any changes to data on storage media. Ensure that evidence remain in read-only state. And incorporate other evidence source when you're submitting the, like example, you took the picture of the crime scene, you capture the logs of other systems also, by which you can set up the things. So that something can be done. Now the role of an auditor. As a CISA auditor, how you audit the forensic investigation process. So first you see the data protection. You have to see, do they have any protocols by which they're collecting the electronic evidence? Do they have a protocol? How they're notifying the relevant party about the evidence preservation? That's something we have to check for the data protection. Second is infrastructure and processes. So you need to maintain the robust incident response and forensic investigation infrastructure. So we have to ensure the processes are in place to support the effective evidence collection handling. That something is there. Then we have a next important thing called as a data acquisition. You have to see what is the method they're using to transfer all the relevant data. Verify the device are write protected during acquisitions. Capture volatile data, collect the volatile data like open ports, active process, user logons. So that would be lost upon the system shutdown. So this data is critical for reconstructing state of the system. So are they collecting properly? Do they creating a bit by bit image? So it allow the recovery of deleted files, fragment files, residual data. What is the process of extraction they're using? Identify this and select the relevant data. Okay, interrogations, analyze the extract data to identify the indicators such as telephone numbers, IP address, use a technique like correlation, graphing, mapping to build the investigative hypothesis. Are they following that or not? Are they converting into common format? Do they have a proper reporting? Because we have a two type of reporting: technical reporting giving to the IT team, and non-technical reporting given to the management team, because sometimes it's a regulatory requirement. Along with that, we also need to check what is the process they're using for the data file recovery. So we have to make sure recover and restore the files that appear to be deleted. So we involve the searching of system memory, reverse technography, and we have a cross drive analysis where we compare data across the multiple drives through the correlations and everything and detect the anomalies. So these are the stuffs what we are using. Along with that, we have to see how they examine the volatile data which is performed in the forensic labs, and are they using any kind of a statistic forensic where they use a statistical method to reconstruct the past activities. So because that can help them to understand the event. So this is all from my side on the domain 5, and this is all from my side for CISA series. Do let me know once you pass the exam in the comment box whether you passed or not. That may motivate me to make more videos on other topics. I'm planning to make a very few videos now on certification prep, and I'm planning to make more on skill-based videos because I believe that give you jobs opportunities better. But do let me know how do you find my entire 5 domain series, and hope you find it useful. Is it different from other videos? And anything is required to improve, do let me know. I will use that particular techniques to improve my content. Remember one thing, without you, I'm nothing. Today, whoever Prabh Nair is because of you. I'm still learning. I'm still a student. Your feedbacks are very important. Stay tuned and do subscribe to the channel and click on the bell icon to make sure you should not miss the future videos on a similar topic. Good day. Bye.